Hey, okay, it works. Alright, we are waiting on Sharky. I don't know what he's up to. Wow, notification squad. Already 3 concurrent viewers. Apparently Sharky is tutoring. I don't know. Not sure about this.
Alright.
Oh, hi! Okay, you're here.
Yeah. Sorry about that.
Cool, okay, can you say something?
Yeah.
Cool,
Hello.
okay, everyone can hear you. That's good. Nice. Now
Okay.
let me just adjust.
Sorry about that.
Oh,
Hopefully
good.
I wasn't too late.
Should we start at 35 as well, like last time?
Yeah, probably. We started last time at 35, right?
Yeah. Did you get the Jamboard link?
Let me check my emails. Should have. Yep.
Cool.
Open Jamboard.
Copy video URL. Make
I
an
should probably
announcement.
close the old Jamboard. Come on. Close, there we go. Are we live right now?
Yep, we are. We are already
Okay.
live.
So you told them.
Yeah. Wow, nice. Isn't this really early for you to get up and like tutor people?
Yes.
Wow.
But that was only because I was done later, but this thing wasn't happening, so yeah.
Oh, I see.
Yeah. Okay, I'll flip over to tablet mode and now I can handwrite stuff. Just time to get the questions up. Get the marking scheme. Okay. Oh, day 2. If the room is to be true, we're facing a combi question paper.
Yeah, I've heard that.
Yeah.
This will be fun.
At last, CCC in real life.
Yes.
Christmas combi contest, but Christmas was in July.
Yeah.
Well,
I mean, it's
December.
closer, you know?
Yeah.
Closer than July to Christmas.
Yeah.
Alright. So yeah, it seems like 4 and 5 should be alright, but then 6, who knows? Let's see if we solve 6.
Okay. So you should start pretty soon, I guess.
Yeah.
Okay.
I'm gonna go
Have you got probably have you got your paper and everything?
Yeah, I'm about to
Yep.
download it.
Yep.
Alright, let's start then.
All right, let's go. It's a long question.
It is.
Car companies operates cable cars. Each cable. No one. Which starts. Wait, what? And the cable car which starts higher also finishes higher. What do you remember that? Two stations linked by company.
Big problem.
Wait, what? I do not understand this question completely. Okay. So you have like what, n squared elevations or something, basically, and you've got
I've
k
pasted it in
like
the Jamboard, so I can read from there.
yeah. Do you
Okay.
understand the question though?
I haven't read it yet.
Ah,
Uh, I,
do you understand?
okay, so I think like they're Okay, I think.
Like the way I'm understanding is like okay, you have like n squared like points on a line, like a
Yep.
vertical line, and you have like edges between these points, like directed edges going only upwards,
Mm-hmm.
and like there's k edges of each type. Like there's two types and k edges of each type,
Yep.
and they all don't share and the end point start point or end point. Is that it?
Uh.
So like it'd be something like if I should do this maybe like I'll do like this
Yeah.
5 6 and then you'd have let me do different colors. So red would be like A, there'd be like something like that, and then there'd be something like that, and there'd be something like that, and with blue it'd be something more like wait yep so k different starting points yeah and then for B it'd be something like that, and then it could be something like this, and then like something like
Yeah.
that.
Yeah. This is how I
Yeah.
understand it. So this would obviously work because the second and fourth ones are both linked, right?
Yeah.
Interesting. Okay. Um.
But it's n squared
So
stations. Oh wait, my bad. It's just like
true. Yeah. Yeah.
whatever.
Guarantee there are two stations.
Yeah, but it's something like this, I think.
Yeah.
It's a bit worded a bit weirdly though. Alright, so you're the combi expert, let's go.
Okay. So I'm thinking. Um. Can we put this? Can we like get this information on a grid? I think we can, right? So like, okay, so you take a n squared by n squared grid,
Mm-hmm.
and on the horizontal you have the starting points, and on the vertical you have the ending points.
Right.
Um,
Wait, there's an obvious lower bound, right? Like n squared minus 1/2 or something.
yeah, yeah, yeah,
Yeah. Because you can just like have it separate.
yeah, exactly.
So
Well, n squared. Well, it depends if n is even or odd, right?
well, does it not matter in this case with my n squared minus 1/2 thing?
Right. True. Yeah.
Yeah.
Um, okay, so yeah, let's just try stuff. I'm gonna get a 9 by 9 grid up, I guess. So I'm gonna rub this out
Yeah.
if you don't mind.
Sure.
Um,
You said none, but oh, you're doing a Sudoku.
Yeah, kind of.
Yeah. I was like, okay, yeah.
Cool. Time to try cases.
Yep.
So basically, I guess we can label like points blue or red, depending if it's A or
Yeah,
B.
yeah.
Yeah. So obviously, a point cannot be both blue and red because that's just a trivial case and it just works, right?
Yeah.
And also, I think the blue points have to form an increasing sequence, and so do the red points. And
Yeah.
also, you can't have any points below this diagonal. Well, actually, I guess below yeah, below this
Well, yeah.
diagonal.
Yeah.
Great. So
Is this a number theory question now?
I don't know if it's supposed to be one. I mean, surely
Nah, it feels too complicated.
they. Yeah, I mean, I don't know. I feel like they would try to at least pick. Like, they wouldn't intentionally pick three combi problems, right? Surely. So
Yeah, yeah.
I feel like they probably wanted one of these to be like number theory, and it just turned out to have a bit of combi in it or something like that. I don't know.
Yeah, but problem 5 is actually number theory.
Oh yeah, true. Yeah, okay. And oh yeah, nice. So problem 6 is combi giro.
Yeah.
That's nice. Oh my god, it's one of those problems. Do you remember the problem 6 like a few years ago, with
Yep.
the yeah weaker results will be awarded points depending on blah blah blah. Yeah. Oh, that's a nice.
Okay, so
Yeah.
this isn't the number theory question probably then. This is actual combi.
Yeah, I think so.
Yeah.
Likely.
Wait, so is it squares or nodes that represent our thing?
Squares. So for example, if I put a
You
blue
can-
point here, this would mean that there is a blue. The blue cable car company has a cable car going from 1 to 6.
Okay.
Yeah.
And you can still have something like 2 to like 4 or something. That's 3. 3 to 4. You
No,
can still
you
have something
can't.
like that.
Yeah, you can't have this because remember
Why not?
that higher starting points means higher finishing points.
Yeah, it's still higher starting point, right?
Yeah, but the finishing point isn't higher. The finishing point has to be bigger than 6, right?
What?
Because
I didn't understand that sentence that gave in that problem. To be fair, so I have no clue.
you mean
It just
the thing which starts higher was the finishes higher?
yeah, I
So-
didn't fully understand what that means.
So I think it means that. So we already have a cable car going from 1 to 6, right? So if some cable car starts from greater than 1, then it has to finish greater than 6.
That doesn't sound like that's what it's saying though.
Really?
Am I bad at English?
I don't know. Damn it, do we get 30 minutes question time?
Yeah. Guys, Livesolve chat. Can you
Yeah.
explain?
Yeah.
Yeah, this is actually like
We're not sure we
Bad
understand
English.
this. Yeah. Okay, well, so my understanding is that like if you consider the distances as intervals, then you can't have nested intervals basically.
let me think about this a bit. I swear to God, this. Oh, who joined? Brainy?
Oh, hi Benny, he's muted though.
Yeah, Brainy, you muted.
Yeah, so if you want to ask a question, you have to put it in writing and then ask it in Livesolve chat.
All right, let's do this. All right. So what's our question gonna be?
Okay.
By cable car which starts higher also finishes higher. Do we mean that if A has a cable car going from 1 to 6, then any cable car from A starting from greater than 1 finishes greater than 6. Okay, I sent the question in Livesolve chat.
Right.
But like, I feel like that would make sense, right? Because I mean, what else could it mean?
Yeah.
Wait, what do the arrows
Yeah.
mean?
I'm still not completely used to the notation. I'm just trying to see,
Right.
can you make a better bound than n squared minus 1 over 2?
Oh, right.
Like, even with, like, without, like, understanding the question completely? I don't know.
I mean,
Yes, that is correct.
okay.
Alright. Okay, Nick.
So yes, I think that means that the blue points are increasing, right? Surely that's what it means. Like,
Okay. That's what it means. Okay.
so you can't have a blue point there. Like, you could have a blue point like maybe here, and then like here and here or something like that.
Yeah. So it's asking for the most number of points you can choose along there that, like,
So I think we can even
won't
knock this
share.
out, right? Like, all of this. This is
Yeah.
unnecessary. Actually, I'm not going to rub that out. I feel like, well, I don't know. It might be useful, and I don't want to have to draw it again later.
Okay.
Okay, let's see. 1, 2, 3, 4. Right, still none are linked yet.
Make this. Right. So you can't have blue and red in the same row, right? Wait.
You
Can
can,
you?
you can.
Then what stops, like, this thing? Just like.
Because you can go from 1 to 3 using red, and you can also go from 1 to 3 using blue.
Wait. Oh, right. Okay. So it's like vector addition.
Is it?
In this plane. That's not helpful, but
But I think I found... I mean, like, if we use the previous configuration for blue points, I think you can have more than n squared minus 1 over 2. Oh, wait, actually, hang on a minute. Oh, never mind. Oh. So, Yeah. If you have n squared minus 1 over 2, that means there has to be 2 points in the same row and 2 points in the same column, right? By pigeonhole.
Right. So we need a rectangle.
No, we get like a triangle thing-ish.
Oh, the triangle. Yeah, 2 points in the same column. Okay, yeah, not just Okay, so that means could you? Oh, I see. It's like that question where it's like you have to place coins on the chessboard so that it's like triangle free or whatever, or rectangle free.
Oh, is it? Okay, interesting. I didn't realize this
Kind
was
of.
similar to that. But that was like a question too, wasn't it?
Mm.
Anyway, yeah, so I don't think there's a problem with having like 2 points in the same row or column, but maybe if it's both, then it doesn't work. I'm not sure.
Yeah. So I'm just thinking, how would you range it so it's like nice?
So here you'd be able to go. Okay, you can do that. Well, here's an interesting arrangement.
Yeah.
But can you add one more red and one more blue? I don't think you can, right?
No. What if we do this real quick? Put in a blue like here instead. And then I put a blue up here. And then put blue up here. And then no, that definitely doesn't work.
Yeah,
Okay.
no, that doesn't work, yeah. So I think, okay, this reminds me of, you know how, like, we had, like, an Andy the Ant problem a few years ago. I think it was by 10, and the solution was something along the lines of, like, it had to do with if you have a graph with n vertices, then if you also have n edges, then there's a guaranteed cycle.
Right.
Which is a trivial fact in graph theory, but
Yeah. So what our current value for k is still n squared minus 1, 2.
Yeah, I think so. And so let's say we put a blue point here, I guess, or something. Now, if a red point is, say, like here,
Then this is like blue cross. This is just a cross, sorry. Wait, undo that. It means you can't have a cable car here.
Oh, wait, what? No, it means you can't have a cable car here, right?
Oh, right, yeah. Okay, my bad, yeah.
Yeah, but that's not very strong, though. I mean, you can still have a cable car here, for example.
Yeah.
And then...
See, I didn't like this notation. I still prefer the good old line up the mountain thing. Because that's a bit more visual, I think.
We can use that, yeah.
Yeah. Okay. So let's see what your thing is again. So your thing is 1 to 2, 1 to 5, and you can't have 2 to 5, but we have 2 to 6. No, 3 to 5, sorry. Okay, let's swap that out. Let me undo it. It's faster. No. There we go. So we have okay. Should put red on the left and blue on the right. Okay, what's a nice way of arranging these? I feel like this. You go like this. Then you go like that there, then that there. Then if you go red, you go like that. Does that work? Wait, no. Go like. Wait, no. Doesn't work. You can go like that.
Hang on, doesn't this work? Wait. Hang on, how do the red things work? Like, you can't have the same starting point.
Oh crap! Yeah, my bad. That was I'm like, wait, doesn't this just work? Okay.
So this would go from here. Okay. I think this works. I managed to put 5, I think.
I'm trying to put 6 in.
Yeah, that seems hard.
Yeah.
So
Like you
basically...
got 6 blues.
No, wait, what? How do we get 6 blues?
I have 6 blues, as in I have 6
Oh,
blues
right,
here.
right.
I'm trying to put a few more reds.
So, like... Yeah, what I've realized with this
Yeah, you
notation...
can your reds. Well, my bad. You can do this totally. Right?
Nah, because these 2 points.
Alright, okay, sure you can shift it a little. No, can I?
What about if you put this blue one up a bit?
Yeah, I'll put that one up there instead. Yeah, that would be better.
Okay, cool, got him. Actually, I think you got a construction, and I think the construction is probably the best, just judging by, I don't know, intuition. So it's 6 for each, right? So I think
Yeah,
new bound
okay.
is so basically you like group them into groups of n, and for each n, like blue just connects each n, and red connects them like mod n.
Yeah.
Right?
Oh wait, yeah, it does. Yeah.
Okay, cool.
Yeah.
I think so. I think that's a
So
good
this
bound.
is like. So red is like your bijection between cosets, and your blue is
like
just
for each
coset addition.
pretty much yeah.
Okay.
Cool. Okay. So yeah, I
What
guess.
does this look like
How
in
do
your
we put these?
notation? I'm just curious.
Sorry.
What
In
does
my
this look like in
notation?
your notation? Yeah.
Well, so basically, I figured out that in my notation, you can't have a rectangle with like so each of the points on the diagonal counts as a point, and you can't form a rectangle anywhere.
Yeah.
Anyway, so using my notation, it would look like.
Yeah, I'm just wondering because this may just prove that yes, this is a lower bound, but now we have to actually prove stuff. So maybe your notation works.
So you go. Oh, right. So your notation. So your things do this. Okay.
Oh, cool, that works. And you're like, wow. Okay, that's cool. Yeah, that kind of makes sense why that's optimal.
Yep. So
Because this is closely matched.
our bound is now n times n minus 1.
Yeah.
Um.
Well, n squared minus n plus 1, right? Because it's k. It has to be guaranteed.
Isn't that just wait what?
N squared minus n plus 1, because n squared minus n, we've shown that there exists a way, so there isn't.
Oh, right.
Yeah.
Yeah. Okay, sure. Yeah.
Okay. Wow, that's much stronger than before.
Yeah. So the question is, why? Oh, okay. I think I have a pretty strong
Conjecture.
Well, so if you have that, then that means that you can't have any points in this triangle or above.
Yeah,
And I think that's pretty strong.
kind of makes sense. Yeah, because you've already saturated the diagonal below it.
Yeah, exactly.
Okay, yeah, okay.
And you're also trying to not make any rectangles.
Yeah. I'm still not completely sure on how your description of rectangles works here.
Oh, so a rectangle would be, for example, if you had a red point here, then a rectangle would be formed with these four.
Oh, with the diagonal point.
Yeah.
Okay, yeah.
So diagonals also count as a point. Yeah.
Okay. Cool. Okay.
And
wait, then what's the diagonal form if you have like a blue over just wait, over here?
so it's not the So it's definitely not the only. So
Right. Okay.
what I mean is like so here you would form a rectangle with. Well, it's not a rectangle, but it's a cycle, right? Like this.
Yeah.
Oops. Wait, what just happened?
I just deleted it,
Right.
but yeah.
Like, it's
Oh,
like
I
this
see.
cycle, like that.
Okay.
Yeah. So this is giving me big Andy the Ant vibes.
Yeah. Yeah, this is like reflections and stuff.
Yeah.
Like if these are mirrors and all that. There's that's interesting. Wait, so that means we could reflect these points over the diagonal, right? And then we need no rectangle. Yeah?
No, because well, okay, if you reflect all of them, yeah, okay. Oh, wait, actually, no,
Yeah.
I still don't think that's necessarily true, because what if you have a chain of 4? No, I don't think it's true actually.
Wait, why not?
What if you have a chain of 4? Right, it would look like 1, 2, 3, 4, and you'd have a red point here, right? And you wouldn't even form a rectangle if you reflected it. You actually have to do the cycle.
Wait, why wouldn't you form a Okay, yeah. And you reflect it over,
Right,
you'll get
you'd get this point if you reflected it over. Actually, wait, you would get. Yeah, okay, exactly.
wait,
Not that
not
point.
there.
Yeah.
There. But you get over here.
Yeah, and they're rectangles.
Yeah. Because reflection means you always get rectangles, right?
Huh?
Wait. Is there not a rectangle? No, there isn't, is there? Okay.
No, yeah.
Damn. Goddamn reflections. Please help. How else can you characterize those shapes nicely, though?
Actually, I think reflections might actually help. So here we have a 1, 2, 3, 4, 5. A 5 by 5, right?
Yeah, but there's the other two corners aren't like. Oh, because they're diagonals, right?
Oh.
Yeah, because you have to include the diagonals, right?
Yeah, of course. So if you have more than n points in any n by n square, I think it works.
Because pigeonhole.
Maybe? I'm not sure actually about this, but that's a conjecture, I guess.
Okay.
And you can see in our construction for any. Oh wait, hang on. It has to. Wait. Wait a minute. So.
Wait, maybe there's just some nice pigeonhole argument. Because
Yeah, maybe. Yeah.
like there's a lot of things. So like,
Yeah.
like just pigeonhole in this thing, like in this trapezium thing. Okay, n squared minus n plus 1 is like what? That means what do you have? It means there exists like what? A chain of 3 in this case. Like we get like 3 consecutive car things. Do you? Wait. Am I doing this right? Wait, yeah. So if there's there's n minus 1 starting positions, right?
Mm-hmm.
So that means that if the k is equal to n squared minus n plus 1, that each starting position will be able to reach, like there exists a starting position that reaches n. Wait, no, it doesn't work, does it? Do I even understand this question well? Wait, so n squared. Wait, yeah. So if you have there's n minus 1 starting positions, right?
Yeah.
Yeah. So since there's at least n squared minus n plus 1 like things, right? K will like whatever's.
Yeah.
Then there's what? There's at least n plus what? N plus 2. Sorry, yeah, n plus 2 uh lines like things going up on like what at least one of the things, one of the stations.
Wait. Say that again.
Okay, So from one of the starting positions,
Yeah.
it's like n plus 2, at least n plus 2 things going away from it. N plus 2 lines. Like okay, how would you define this? So you consider this path in the red path 1, 2, 4, 2, 7, right?
Okay.
So like you consider like that thing as like a path, and you consider like all such possible paths.
Okay.
Okay. So then the total number of lines along all the paths is k.
Right. Yeah.
Yeah, for a company, and there's going to be at most n minus 1 paths, right?
Yeah.
Okay. So if there's n minus 1 paths, if there's at most n minus 1 paths, and there's at most n, and there's n squared minus n plus, and there's at least n squared minus n plus 1 lines, there exists a path with at least n plus 2 lines.
Oh.
A pigeonhole?
N plus 2. Wait. Hang on.
Yeah.
But like, so right now, right? Like, if we consider this arrangement, then
Yeah.
each path. Oh, right. You're saying like the number of stations it includes.
Yes, that's it. Yeah, that's it. Yeah.
Oh.
Which is like
so
a bit more than we require. But
Wouldn't
like
it be
it's
n plus 1? Because it's 4, right? In this case, if we add another red line.
n squared minus n plus 1 is like a greater than n squared plus n squared minus 1, right? For n greater than 1.
Wait, sorry. What? Say that again.
N squared minus n
Yeah.
plus 1
Yeah.
is greater than n squared minus 1
Minus n.
for n greater than 1.
N squared minus n is greater than n squared minus 1? Wait, so
N squared minus n plus 1. Yeah.
you're saying this? Sorry, n squared minus 1.
Yeah.
What? That's not true.
Wait. No, never mind.
But I
Did
think
n squared
I
plus
think I get
n
your
minus
idea.
1?
Sorry?
But yeah, okay. So if there's n minus 1 lines, there's n plus 1. Yeah, so it is n plus 1. Sorry, my bad. I can't multiply. Yeah, because it is n squared plus n minus 1.
It would be n
Yeah.
plus 1. Yeah.
Yeah. Okay. Yeah. So if it's n plus 1, then that means it visits like every single stop, basically, right? It has to. But then you can do the same for the other company.
Wait, what? Every...
Wait.
No, it doesn't. What?
Okay, if there exists like a what you call pathway that has n plus 1 lines on it, then the same exists for the other one.
Yes.
So that means there exists that, but since there's only like n of, like there's only like wait, does this even work? No, that's because I've been doing n points, not n squared points. I've explained it. That's why the conclusion doesn't. Okay, but okay, so we have this weird thing though. We have like a lot of cable lines though per path.
Yeah.
Okay, it's n squared things though, not n things.
Okay, hang on. Okay, I think I might have gotten it. So I think we can make your argument work. So what we do instead is so we consider each path, right? So for example, from here, the red paths are 147, 258, and 369.
Yeah.
Now, if we have if we add one more red path, right? Let's say we had 7 red paths. Then one of the paths would have 4 stations in it, right?
Yep. By my thing, yep.
And wait, hang on.
And similar for like the blue, there'll be one with 4 things on it.
Yes. I mean,
so does that guarantee them to?
So, but hang on. There are also 3 different blue paths, right?
Right.
Um,
Well, there's n different blue parts at least. Wait, at most.
and
Okay.
each path. Wait, how does this work? This worked in my head. I just a moment ago. Wait, hang on.
Yeah, I need to think about this as well. This is
Yeah.
like big pigeonhole. This is an old pigeonhole. Okay. Squared things. Then we have n squared minus n plus 1 thing. So
Oh. Hang on. So, the so each side. On the blue side, you would have n squared minus n plus 1 paths.
no lines.
Oh, sorry, lines. Yes. Well, cable cars, right?
Yep.
And on the left side, there is a cable car with. Sorry, there's a path with how many stations? N plus 1, right?
Yeah.
That adds up to n squared. Wait, hang on.
N squared plus 2.
Oh, right. Oh, yeah, n squared plus 2. So that finishes, doesn't it? Because there's
Oh,
n
okay.
squared.
Okay.
Wait, does it? Hang on.
Wait. Okay. Why is okay? Let's recap the logic because I'm now doubting all my logic because I've been thinking like
Just n instead of n
stations.
squared. Right.
Okay. So why are there n plus 1 parts?
No, there aren't n plus
At
1
least.
paths, but there is a path with at least n plus 1 stations on it.
And that is because
That is because
this is doing my head in.
it's because there are okay, so there are n squared minus n plus 1 paths. Sorry, no,
Lines.
paths. Yeah, or arrows. Yeah, and
Yeah. Well,
surely,
suppose
yeah,
every
I'm pretty
line.
sure. Yeah. So like every line has a start point and an end point, right?
Yeah.
And it's all different.
So you can probably bound it or something.
Yeah. I'm pretty sure. I'm just trying to figure out how to like
Yeah.
do the algebra.
Why the hell is this harder than yesterday?
Yeah. This has taken us almost as long as problem 3 so far.
Oh my god.
Wait, so 1, 2.
Okay, suppose there was n minus. Well, okay. Each line has at most n parts. That's right. Okay, there you go. Each line has at most n. Each part has at most n lines. Sorry, right? Yeah.
Each path has at most n lines. No, you can have a path with more than n lines.
No. Wait. Oh crap! Again, I did it again. N squared.
Yeah.
N squared. Okay. parts. So, but they're all disjoint. So that's let's think of it as sets instead. So you have like
Yeah. So here we have like 1, 4, 7,
1, 2, and squared.
2, 5, 8, and 3, 6, 9.
1, 2, and squared, and you're separating it into what? Like,
Wait, is it true that
Can you have more
of
than-
course. No, exactly. So the number of paths and the number of cable cars is at most n squared, right?
Yes.
That's the bound, I think.
What?
So if we add one more cable car, if we add one more red cable car, there can only be at most 2 paths, right?
Yeah. Wait. Let me think about this a bit more. Okay. Can there exist n parts? Can a company have n distinct parts?
Yes.
If k is greater than n squared minus n.
Oh, right. Then
Like if k is greater than n squared minus n+1.
Then no, because cars plus paths equals n squared.
Yeah.
It's actually less,
Okay, so that's
less
it.
than or something, right? It's an
Yeah,
inequality, but
so
let's just say it's equal.
So that means there's at most n-1 parts. Right?
Yes.
Okay.
Oh, right, and that means there has to be one with n plus 1.
Yeah. Okay.
So, okay,
Is that it then?
Okay, so hang on. So, there is one with n plus 1 stations, and then the other one, you have n squared minus n plus 1 cars. Yeah, so like even if you try and fit them in between the n plus 1, you won't be able to because they sum up to like way too big.
Yeah, okay.
They sum up to more than n squared or something like that. So like
n squared plus 2, right?
Yeah, so if we consider like, a red path 1, 2, 3, 4 or something, and then we're trying to fit
Yeah, I get how it works because it's like you have n squared stations. You can have at most like n squared cable cars. They're like
yeah. So you can share at most 1. So if you have a blue line, it can share at most 1 station here, but you have 7, so you have to go like 1, 2, 3, 4, 5, 6, and that's 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, that's like 11. Wait, hang on.
Yeah,
exactly. Oh, right, exactly. That's why it doesn't work. So the last one has to go at most over to here, and it joins again.
Right.
Okay, so I think that's solved.
All right. Oh my god. That was Q1.
Yeah. Rip. Great. So clearly, Dave ordered all the problems in complete difficulty order this year. So problem 4 is like harder than problem 3 now. Yeah.
Yeah.
Oh my
Q3
god.
made sense. What the hell? Q4 was.
This was. I mean, okay. I liked this problem to be honest, but like it's just confusing to think about. I don't know.
Yeah.
I feel like it's because I don't know. I feel like if I was doing this in the actual competition, I wouldn't have this much difficulty. But yeah, I don't know.
Yeah, and probably it's me because I kept fake solving or whatever.
I don't know. Yeah, I feel like and like the grid thing turned out to be not that useful, I guess. Or maybe there's like a nice way to do it with grid, and we just didn't see it. Or I don't know. Yeah.
Okay. Q2. Did this take us longer than Q3? Yeah, it did.
Q2?
As in
No.
Q5. Q5, whatever. Yeah.
Q4?
But as in Q4 took us longer than Q3, right?
It took me like the same time, same amount of time. I mean, okay, I guess
Oh,
that took us longer because, like at the end of Q3, right? We were like discussing other stuff.
Yeah.
So yeah, I guess it took us longer. Confirmed. Question 4 problem 4 harder than problem 3.
Yeah.
Yeah, and also by the way, I just realized why it adding up to n squared plus 2 matters. It's because you need 2 to be in common for both.
Exactly.
Yeah,
You need two in common.
okay, exactly. Yeah, okay.
Okay. Q5, let's go.
Oh man. Okay. Let's go.
What? Arithmetic mean of the numbers on each pair of cards is the geometric mean of the numbers in some collection of one or more cards. Okay. Which one just follow that the numbers on the cards are all equal. N equals 1. No, wait. N greater than 1. Okay. N equals 2. Let's see. That means that A plus B on 2 is like square root. Is either A, B, or square root AB.
Hang on, I'm still adjusting
Right.
this. I haven't read the problem yet.
Okay.
Looks good. Back to here. Paste the problem in. All right, let's go. A deck of anything one cards is given.
Yeah, this is definitely number theory. It's like there's a combi element. So this is number theory.
Yeah. Oh. Okay, interesting.
Yep.
Yeah.
This is N equals 2 works.
Right. Okay.
Try N equals 3.
Okay. Let's log. The deck is in non-decreasing order.
Wait, if any two numbers are equal, we can remove the number, right?
Um.
You can remove one of the numbers, like if two of the numbers are equal.
Can you?
Because arithmetic mean of pairs.
Yeah, but what about geometric mean? Oh wait.
Oh, right. Wait. Yeah, that would be affected. Square root of 2 times cube root of 2 times 2 times 3 is not the
Oh
same as square root of 2 times.
Exactly. Yeah. Okay.
Okay. Okay, so like if
But we can. Yeah. Let's just put all the cards in non-decreasing order or something, so that it increases.
Sure. Not sure how useful that is, but
I mean, like it's useful for us, right? Just like denote stuff.
yeah. Let's try A, B, and C. And it's like non-decreasing, whatever.
Yeah. And then,
Then we have this.
Yep.
And same for like the other AMG arithmetic means. If it's A or B, then A equals B.
So if two numbers are the same, then hang on, no, never mind. Yeah. Oh, also, oh right, I forgot that it's positive integers.
Yeah.
That's quite strong, I feel. Now we can look at like, oh, I don't know.
Expansion time.
Okay, so here we go. What about the arithmetic mean of the largest pair of cards? Because that's pretty strong, right? Because AM, GM.
Yeah. So, but that could still be like, wait.
Yeah, I feel like that's pretty strong.
Yeah, it has to be right.
Doesn't that mean the largest two cards are the same?
Does wait? That is quite strong. Yeah. Wait. Because yeah, AM greater than GM.
Yeah,
So
exactly.
therefore, it can't be square root of that. So that means it has to be the actual number, largest number itself.
Yeah, I'm pretty sure, right? So.
Yeah. That means the largest two numbers are the same. Yeah.
Okay, good. Okay.
So, can you put this in decreasing order so that I can keep using this notation? I don't know.
Decreasing order as in like A is the greatest, and then so on.
Yeah.
Sure. Yeah. Okay.
Because I have A equals B here.
Oh, right. Sure.
Yeah. Okay. So now let's just say A greater than 2.
By the way, is that
Okay,
your
see?
notifications or my notifications?
Mine,
Oh,
maybe.
right. Okay.
I'll meet my Discord notifications
Yeah, you have
somehow.
so many. Yeah, we get it. We get it, Sharky. You're
Yeah.
popular.
Yeah. I'm sorry. I'm too popular.
Oh man.
Okay, there we go. Okay, let's see if that works. Oh, I literally turned off notifications. What the hell?
Oh, also, don't we have that the bottom two numbers? Okay, never mind.
Sound message off. There we go.
It actually might be more. It might be better to start at the bottom two numbers.
Oh, wait, because the bottom two numbers are the same as well.
No, I don't think so. Because you can have
Why not?
bigger numbers for geometric, right? Like later, the bigger numbers can be used for
Oh, right,
geometric.
okay. True. Okay, so...
But what you can do is you can like you can like prove the existence of certain numbers.
Yeah.
If you start with the bottom two.
Yeah, so let me just rub all this out and Okay, so let's start with n equals 3. And we go a less than equal to b less than equal to c. Then b equals c.
Yes.
Okay.
I think in the 3 case, this also means A equals B equals C, right? Surely.
Let's find out. A plus b over 2 is going to be... The only time it's not directly obvious is if this is the case. Not b, that's 3c.
Also,
Like this, when it's like this.
all numbers are either odd or all even.
If they're all even, can divide by 2 though.
Alright, so they can all be all odd, right?
Yeah.
Okay, so we log all numbers are odd. Cool.
Yeah. Okay, now, do there exist any solutions to this equation?
Wait, why did you have A squared C? Because you're only allowed to do A once, right?
Geometric mean of the some collection of one or more cards.
Wait, can the cards repeat?
Well, it just
Surely
says
not.
we proved B equals C, right? Wait, A. Oh crap! This should be AC squared. My bad.
Oh right, I see. Yeah.
Oh wait, I mean it could even just B, whatever. Do there exist solutions to this though? Feel like there shouldn't be. Like this, what like this?
unless they're both equal, right?
Yeah, unless A equals C. Okay. Like it's not even homogeneous. What the hell?
Surely you
Wait.
replace C with C over 2 plus C over 2. Does that help? Oh wait, no, because then wait a minute. No, because the denominator will be 3, right? And then yeah, it doesn't work.
Yeah. Wait, but I can factorize. Okay, let me just factorize real quick. So it's a cubed plus 3a squared c plus c plus 3ac squared plus c cubed equals to 8ac squared. So if you subtract it, we get like a minus c, a squared plus 4ac minus c squared. Yeah. A equals c, or a squared plus 4ac equals c squared. This is like via the root jump. Not even via the root jump, which implies like a on c squared plus just do the thing, you know.
Yeah.
A on c minus 1 equals 0, and this is like got no solutions in rationals by rational root theorem.
Okay, cool.
Yeah, so this is impossible.
So then for n equals 3, it's also true?
Yeah.
Okay.
So there's a better way of proving this though.
Now, by the way, if we just take the largest card and the next largest card, so as in like, let's say like all the largest cards form like are the same card, or like not the same card, but like let's pick one of the largest cards, and then pick the next largest card.
Okay.
Does it even work?
Then that was the geometric mean of like some of the cards, like some of the big cards.
Oh yeah. So basically, there has to be enough big cards so that the geometric mean makes up for the like deficiency of the GM. Yeah, okay. Interesting.
Wait, if a prime divides any of them, then it has to divide all of them, right? No, it doesn't. Does it?
Why would it?
No, would it? Well, because it won't get cancelled down in the arithmetic mean, right?
Sorry?
It won't get cancelled down in the arithmetic mean for a prime p.
Yeah.
Like if 3 divides 2 of your cards,
Yep.
then it divides your arithmetic mean, so that means it
Oh.
must be. So you have like some divisibility condition there. So not what I've said before, but like you have some divisibility thing going on as well.
Yes. Why would that not imply every card it divides that prime? That prime divides every card, I mean.
Wait.
It would, right? Because let's just say you have, let's say you have 3 divides A and B. Then you look at A plus B over 2, right? That divides 3.
Yeah.
And this has to equal some GM. Now, the GM... Yeah, if...
You can't have both A and B. And
Wait. Oh, no. You can have some, like... Some numbers might divide 9 or something. And then you can have other weird things. Yeah, okay, true. Okay.
I still feel like we should be looking at like probably the unique numbers and stuff.
Yeah.
So like suppose like we say like we have could we just say that here are our numbers like A1, A2, etc. So like AK instead, and then we can just say these are like strictly increasing.
Oh, and we can use like however many of each we want, right?
Yeah.
Yep. Cool. Yeah, that works. Wait, doesn't
And
that
now
just
we.
that
Hmm?
that brings us back to like what I thought your interpretation of the problem was before, where like your collection of cards could like repeat.
Yeah.
Yeah. Okay. Sure.
Now let's think. So that means like if you like consider like your thing with like the largest different one,
Mm-hmm.
AK minus 1 plus AK
Yeah. Yeah.
equals 2. This equals to like the GM
Yep.
of
Exactly.
like
Of sum of
like
AK minus one and sum of AK,
yeah
and
like
potentially other
well
stuff too. But like,
yeah potentially other stuff yeah. But the point is like AK has to be in here,
yes,
right?
yes, exactly, and it has to be in there like
AK
more
in,
than once, at
yeah
least
AK in
twice.
there yeah. So you consider like the prime thing then, right? Because AK is also here.
Yeah.
So if a P divides AK, then that means that P has to divide AK minus 1. Yeah?
Oh.
Like, right? Because the P won't get cancelled out. I think that's what I was saying before. Yeah, because
Ah.
how can the P get. If P
Oh, you
divides.
mean you're
Like, not
saying
like.
because of the GM, right?
Yeah, yeah.
Yeah.
Like,
Yeah.
not
Okay.
necessarily like a. There's no, it won't be the same power of P, but like
Yeah. Exactly.
rad AK would divide AK minus 1.
Uh, I'm not familiar with rad notation, although I've heard of it before.
Rad of P1 to the A1, P2 to the A2, etc. equals P1, P2.
Oh, right, right. Yep, yep. I remember now. Yep.
We used this in the weekly open, if you recall.
Oh, okay then.
Yeah.
That's rad.
So,
Sorry.
yeah, I'm not sure how useful this is.
All
It's
right. Yeah,
like,
yeah,
I
yeah.
mean, it is pretty. Yeah, but you have like this bound, I guess.
But wait, so it does mean that um doesn't it
Wait, but we
mean
can repeat
that
this, right?
yeah, exactly. So you can just do
Yeah, we can repeat this.
so if AK minus 1 divides if P divides AK minus 1, then it has to divide AK minus 2, right?
Yeah.
Because either AK or AK plus 1 or AK minus 1 has to be in the GM, and both of them contain
Yeah.
divide. Yeah, yeah. P divides both.
Why the hell is this much easier? What the hell?
So basically,
We're not
every
done yet,
number
we're not
has
done
to
yet.
divide. Every number has to be like the power of some other number, like the power of a
Wait, but
certain.
did we divide by GCD though already?
Sorry.
Did we already divide out by like a GCD value?
I mean, like you
It's so
can.
odd.
Oh wait.
So, but now, okay, well, yeah, it's we divide out or add by GCD value. We can do that, which means that there must exist a pair of numbers which is coprime.
Yes, and that's supposed to be a contradiction or something.
Well, no, it means that you get one,
Oh wait,
right?
no. It means that all the cards should be equal. Yeah, yeah, and it means you get all ones, don't you?
Yeah,
Okay.
yeah.
So
Is that it?
our conjecture is that for all in, every card has to be equal.
Yeah.
Okay, I think we should go over this proof because there are some moments we skipped some stuff, so or like I'm
Okay,
not
let's
sure
go.
of all the steps. So let's go. Yeah.
So firstly, we can just at the start we can divide out by the GCD. If a set works,
Yes.
then we can divide out through by its GCD because the GCD is not affected through AM and GMs.
Yes.
Yeah. Okay.
So now there's
Next
at
thing.
least one pair that with GCD 1.
Yeah.
Okay.
One
Now-
one
Now
pair.
suppose
'Cause
AK is yeah. Suppose AK is not 1, right?
Yeah.
Then AK is some prime divides AK.
Yeah.
Okay. Then we
So
just,
rad AK divides AK minus 1 in particular.
do we need that? We don't, right? We just need to show that.
Oh, we just need P, yeah.
Yeah, we just need
Yeah.
P. Yeah, yeah. So if P divides AK, then we are supposed to prove that P also divides AK minus 1.
Yeah.
Okay, cool. And we know that
But
because
that's true about that. Yeah.
AK has to appear in the GM.
Yeah.
So that means P has to appear. P has to divide the GM.
Yeah.
And so AK minus 1 has to divide the GM. Okay.
P
And-
divides AK minus 1. Sorry.
Yeah, so P divides AK minus 1. Okay, cool. And then for AK minus 2, we just like use strong induction, right?
Yeah. P divides AK minus 1, so P divides AK minus 2.
Yes.
Same
okay.
logic. Wait. Did we assume that AK minus 1 was in the GM though for that?
No, because
No, wait,
well,
but
it's
AK
either.
AK
This
minus
is
1
why.
would be-
This is why it's
yeah.
strong induction, right? Yeah.
Yeah, okay. Strong induction, yeah, works.
So then AK minus 2, P also divides AK minus 2, and then that means
Yep,
P
and-
divides all of them. But that contradicts the fact that
They are coprime.
yeah.
Well, not
So
coprime.
then
It's just a pair
they're-
that's mutually that's
yeah, unless they're all 1, obviously.
Yeah.
Okay. Oh, but we already assumed that AK wasn't 1. So yeah, that
Yeah.
is a contradiction. So
Okay.
then all of the cards are equal, right?
Yep. The hell, this is way easier.
Yeah, I found this way easier too.
Yeah.
Although I feel like we were kind of like messing around on problem 4 for a while.
Yeah,
All right, shall we do problem 6 then?
I guess. What's problem 6? Wait, how long did that take us?
Much
Took us
less
20
time.
minutes.
Took us. Sorry, how long? What?
It took us like 20 minutes, right?
Took us like less than 20 minutes, I think.
Jesus.
No idea. Okay. Problem 6 time.
Oh no. What is this?
Oh my god. A problem? Oh, right. I was about to say that the problem starts with proof. So I thought there was just going to be one huge sentence, but it turns out it's just consider, and there's a colon. Okay.
Why are the points in S socially distanced?
I haven't read the problem yet.
Yeah.
Okay? Let me laugh at your joke once I have read this problem, okay? Okay. A very interesting problem.
They're socially distanced points, right?
Yep.
This is not a coincidence. Like they definitely did this on purpose.
Yeah. Oh man, they're like coronavirus. How can we see? Even the variable C stands for coronavirus.
And-
Clearly.
Yeah. The N. Yeah.
Yeah. See, CN stands for COVID-19.
Yeah.
N stands for 19. Exactly.
Yeah.
Cool. Okay, so let's just try this, I guess. What about
N equals 2. Well, then you get like midpoint, right? Just do perpendicular bisector or whatever.
Yes. Okay. Wait, hang on. Let's just write. I don't like these fractional exponents. What is this exactly? C times. So
Yeah,
it's
on
just
cube root N.
yeah. C is just the coefficient, and then 1 over cube root n, right?
Yeah.
Interesting. Okay.
I've got no idea how you do this.
Let's just try stuff. So I guess firstly, let's just log the distance between the shortest distance between 2 points is equal to 1.
1.
Yeah.
Yeah, 'cause you can scale.
Yeah.
At least into okay, so it's not like you have
So obviously, like, for 4 points, you can just, for these 4, you can just kind of do this, right? And surely it works.
Yeah, that's what I was thinking. Or maybe like this one. Oh, the wrong way. I got please. Okay, I'm just gonna refresh because I just got desynced.
Oh, right, sure.
Yeah. Let me get back. Okay, there we go. Or you could just send this one. Whichever one's like better.
Yeah. You can probably even do this, or this, or this. There are lots of lines to choose.
Yeah. You just need the minimum distance to be maximized.
Oh, hang on a minute. The minimum distance?
Yeah, it's not the sum of the distance, it's the minimum distance.
Wait, no, wait. Such that from is at least. Oh, right, yeah. So you want the line to be furthest away as possible, right?
Yeah.
So, okay.
Yeah.
So obviously we first so the line has to intersect the convex hull.
Yeah.
Cool.
Wait, it seems like if you have like a really like concave shape, then it becomes really difficult to get big. So maybe there's like where you get your equality cases.
Equality cases, man. Okay. Well, I mean, like, C is any real number, right? So surely if you just put,
Why isn't pen stop working? Oh, there you go. It's back.
Oh, by the way, remember, I don't know if you've seen this, but you know how, like, the perfect scorer guy from China said how he took 2.5 hours on this?
I did not hear that. No.
Oh, right. Yeah, he posted a video where he talked about the fact that he spent 2.5 hours of this. So we have 3 hours right now. So let's go. We got this.
So better than perfect score in China combined. Okay, what would be the best like in this kind of configuration? Like
probably this. Right. This configuration is actually pretty weak. You want something that's like
lots of points, lots of inside points.
Yeah.
I mean, okay, it's weak, but also the bound's like pretty
Oh,
large.
by the way, you need. Ooh. Okay, I have a feeling I kind of get how this is supposed to work, and where the this reciprocal cube root comes from. So, if we consider the convex hull, right? Let's say it's shaped like, I don't know, like this.
Yeah.
Right? So if we just consider the points at the vertices of the convex hull, then you can obviously do stuff like, this line, or like this line, or this line, and so on.
Yeah.
So I'm guessing there's supposed to be some points, like if we consider maybe like, I don't know, the worst case scenario, then we'd have some points here, and here, and here, or something. Which stops us from drawing in these lines. So we have to draw like in the next lines, like this or something.
Yeah, but then you have more points then.
Exactly. Yeah, but like.
You need one extra point to stop working. You need like n plus 1 and 2 extra points for it to stop working or something. Something like that.
Yeah.
Okay, you could also slant your lines. You don't have to be parallel.
Obviously. Yeah.
Yeah, so actually.
So when you have a bigger. So actually, yeah, a bigger convex hull results in way more lines that intersect the convex hull.
Right.
So it also becomes a lot harder to enforce this. Oh, and by the way, You can also do stuff like this, right? I just realized. Just cut off the corners. So that means you also need points like here, like very close.
Yeah.
Actually, yeah, no, wait, no, wait, what was my
But
point?
it's socially distanced, bro.
Exactly. So
Like,
okay, so consider this. Let's say you have a convex hull, and the angle here, I don't know, is like 120 maybe.
okay.
Okay. Oops, no, 120. Then let's say the next point has to be over here. So outside this like circular arc. Right?
Right.
Then we can cross a line through like halfway points over here and here. And we guarantee some distance, right? Which is dependent on the
Yeah.
angle.
Yeah. Oh, do you have
This
trig bash this?
this proves that the angle, like every angle in the convex hull, has to be bigger than some value for it to not work.
So you have to trig bash this then? Do you actually like?
No idea. Maybe? I don't know. Is this where the geometry comes in? This is supposed to be a geometry problem, right?
Yeah.
Like I feel like they categorized this under G.
Yeah. Well, they always categorize combi geo under G.
No, they're usually categorized under C.
No.
What? No?
G8 2017.
What? G8 2017.
2017 G8.
That's like the one of the only problems that was categorized under G. Like most of the time it's under C. If you don't like, I've actually checked this by the way because I've made a handout with
Oh.
like a survey of all the recent combi geo problems, so I remember this.
Okay. Well, maybe they're changing their mind now.
I mean, I feel like with like if you have a problem with some geo emphasis, then it's likely that
Yeah.
it could also go in G.
Sure.
Yeah, and I feel like this has some geo emphasis because as you just as we just discovered, there's like this angle thing. So basically, we need to figure out the relationship between the convex hull and the so the area of the convex hull versus the minimum angle of the convex hull.
So there's like a half and this is a half as well, right? Yeah.
Yes.
So what's this gonna be? It's gonna be like half on 2. So it's like what? 1/2 cos alpha on 2. I don't know if I can trigger it or not.
I don't know.
Cos alpha on 2 equals that over that. So times by that. Oh, it should be this just rather 2. Whatever. Okay, so you have like it's a distance of cos alpha on 2 over 2 or something. So
Yes.
you have to
That's
show
the
us what
distance?
proportion. But how do you create like an actual bound though from this?
So then you do like 360 divided by this, and this tells you how many points has to be in the convex hull, right?
Right.
And because each side length has to be at least 1, that also allows us to calculate the area of the convex hull. Sorry, the area of the area contained inside. Yeah.
Yeah.
Wait, cube root n grows really slowly. I just realized. So basically, even with 8 points, you only need coefficient times half, and then with 27 points, you only need coefficient times a third.
Yeah. That's why it's like okay, it's going really slowly.
Yeah, that is going up really slowly.
Okay, let's find like the most like compact 8 set maybe.
Well,
Let's see if we can.
yeah. Okay, so let's just keep these ideas in mind. Let's go to the next page, I guess.
Yeah. Well, a 4 set you'd want the orthocentric system, so an 8 set maybe something. Whoop. That is a bad point. Let's go like.
I mean, with 4, it's pretty. Like, I feel like 4 isn't very useful.
Yeah, no, but
Yeah.
I feel like it's pretty compact. Like we do like this maybe. No wait, this is like you can just cut the range be a half.
Yeah. You need them to like not be, because if they're collinear or if they're close to being collinear, that isn't good.
Okay, let me go like this instead.
Oh, and also another idea we can use is projections. Because basically you like force a line to be a specific direction and you like sweep it through, right?
Yeah. Well, let's like this.
So you just do this, right? Yeah. So like, since these 3 points are parallel, we project all the points onto this line, and then it's pretty easy from there, I think.
Right. Okay. So you mean none of them collinear, basically?
I think yeah. So I think collinearity is bad.
Let's go like. You have like half.
Although I'm not sure how bad. Here's another idea. So you take the diameter of the set of points.
Right.
And you project every other point onto the line passing through the 2 points on the diameter.
Yeah.
Right, that creates the most space for us to fit another line in. Yeah, okay.
Yeah. Because the perpendicular distance is only one-dimensional. Well, is it?
No, yeah, it is.
It's now. What if your perpendicular distance is oriented? Oh wait, yeah, it is. My bad, yeah, because it's one line only. Yep, so it's all one-dimensional. Okay.
This also captures my last.
You want to have it not quite diameter. I think you wanted like the longest line perpendicular to the line that's like through the convex hull. Not the convex hull. Kind of.
That is the diameter, right? So the longest line, the line with the longest segment inside the convex hull is the diameter.
Yeah. Oh, it is. Yeah. My bad. Yeah, I get that one.
And the diameter not working tells us a lot of information about the points.
Yeah.
Or I hope it does. Anyway, I haven't actually done the calculation, but let's do that calculation now, I guess. So let's say. Yeah, I actually really don't like problems where like there's a constant of proportionality and you don't know what it is. Because then you have to, I don't know. I feel like, are we supposed to come up with an actual number for that, or is it just like?
No, we don't. We just need to show its proportion. It's like you have to show proportion.
You have to show like like big O notation, right? But I don't like doing that kind of thing. Yeah. I really don't like that. Anyway, so let's say that these 2 points are the furthest 2 points apart, and every other point is like you can project onto here, right? So maybe like this point, you can project onto here. So
wait, no, my thing wasn't quite diameter of the convex hull. It's like I think it's more closer to a circle. Yeah, because it's semicircle theorem.
Sorry?
You can see like the smallest circle that contains all the points instead.
Okay, yes, and
instead of the convex hull, right? And you take like the diameter to that, which is perpendicular to the line. You do that instead. Because with the diameter, you lose like your perpendicular distances change depending on how your line is oriented.
No.
Whereas if you use
the whole point
circle
is,
instead,
wait, isn't the whole point that the line that the line is always perpendicular to the diameter?
Well, is the diameter of the convex hull always perpendicular to the line?
Well, that's what I'm
I
saying,
don't think
right?
so.
Wait, what?
Not necessarily, right?
Well, obviously not necessarily, but like if it fails for the diameter, then it tells us a lot of stuff about the other points.
Oh, okay. Yeah, see, I was just thinking, like, if you, I was just thinking, okay, when a good that the line to project onto would be that line, the diameter of the circle thing.
That's what I'm saying, right?
No, you're doing convex hull. I'm doing circle.
Wait.
It's slightly different, but like my thing, you can do it. You can like look at all the orientations of the line instead of just the one which is perpendicular to the diameter.
Oh, do you mean like, we take the...
Wait,
No, I mean like surely if you're gonna project, you want to project onto a line,
yeah, exactly. I am projecting onto a line.
as in
It's
like,
just that the line is the diameter of the minimum bounding circle.
but isn't the diameter...
Because that's going to be very similar to your convex hull thing, except that now you can actually control the diameter. You have control over it as opposed to like it being on the sets of points.
Wait. No. I'm saying, so the line we're
And
projecting...
also, it still contains your diameter. It still contains your convex hull diameter as well.
Wait. Hang on. So my lines I'm talking about aren't the lines that we use to split, to separate the points.
I'm confused.
So let's say that these 2 points is the diameter, right?
Okay, off you. Yeah.
Yeah, and then we have some bunch of other points, right? Now
Okay.
we project them all onto this line, so they become maybe, like, I'll use another color.
Yeah.
Here, and here. Okay. Now you look
Yep.
at the longest segment in here without any points, and the real line is this one,
Yeah.
and this achieves
Okay,
the
sure.
maximum. This achieves the maximum distance for this direction of line.
Sure.
Yeah.
But what if like this line, like if you instead had like this line was better for some reason, like because your diameter might not necessarily orient to like the best possible configuration for your line. Like what if this achieved better?
Sure, but like this tells us, for example, that the red points have to be like, there has to be a red point every blah length.
Yeah.
Yeah.
Okay.
Yeah. I mean, like, for any, like, for any orientation of the projection line, the actual positioning doesn't actually matter, right? All that matters for the projecting line is the orientation that it is.
Mm-hmm.
So, like, the projecting, like, the black line, we can make it, like, here, right? And it would be exactly the same.
Yeah, no, that's fine, yeah.
Yeah.
I'm like, but what if like if you instead projected onto like
Like this line, you
this
mean?
line? Yeah.
Sure, obviously. So we want to consider all the lines, but like I think the most useful
Yeah.
one to consider is the longest one, right? Like the diameter.
Yeah.
And like I don't know, we can consider the other ones
I was
as well.
I mean, I was thinking more that rather than this line, you'd consider like the circle, the bounding circle, and then you consider all possible diameters of that circle.
Yeah, but again, like
And
it
then
doesn't
that
matter.
includes your diameter line, but now you have like full control over the thing.
But like, so you're saying that like, let's say the diameter, the center of that circle is like maybe this point, right?
Mm-hmm.
Then you're saying like maybe we can rotate the projecting line so it's like this.
Yeah.
Yeah, but that's not any different from having the projecting line being over here.
Yeah, but the point is now you have control. Is what I'm saying.
Sure. Okay.
I mean, it doesn't really matter. Like the
Yeah,
thing.
I don't think. Yeah. I think all I'm
Yeah,
saying
okay.
is like, let's consider the longest one first, and then we can consider other ones after. I just
Yeah.
don't think considering the other ones first is as useful.
Yeah.
Yeah.
Sure.
So yeah. So in this case, obviously, if any 2 points if there's any segment of length c1 over root n, sorry, cube root n, then we're done. Because technically we can just half c, right? And then we pass a line through that. Okay.
Wait,
Which
so
means,
since there's n points, right? Then what's the like? There's gonna be a 2 points or at least one over n away, right? Yeah.
is it?
Original. Wait, no, never mind. Wait, is that true? No, it wouldn't be. Be diameter over n. Same thing. Because constant factor or something.
Yeah, so it would be diameter over n. Yes, exactly. Yeah.
Yeah.
So we need to get like the diameter in terms of n. And I don't think that's strong enough either, but yeah.
Yeah. I mean, does it think that it has to be distanced by like? Oh no, yeah, I think it's easy to work with it. Yeah, sure. So diameter over n or something.
So yeah, the question is how do we get the diameter in terms of n? Like the minimal possible diameter
Yeah.
in terms of n. Can we back solve?
That sounds difficult. Where the hell are you getting a cube root from?
As in, like, we say that like it would be sufficient to prove that the diameter is something in terms of n.
Yeah, maybe. Wait, how about we like maybe like give a quantity to like the distance, the minimum distance that there would be, and then like kind of bounded from that. So kind of like what you were saying.
Sorry, say that again.
So like say like the minimum, like you know how we show it's cn to the minus 1/3.
Yep.
So you said that it's like there's always a distance k. Then like your thing you said before, like how each of the other things is also at least k apart. Like every k you go. Can we
Okay.
maybe count the points using that?
Every k you what? Sorry.
Okay, so suppose like the distance is like k, right?
What distance of
The
what?
minimum distance.
Right. Okay.
The
Sure.
minimum distance in L to like a point is k.
Yeah.
So that means every k on your projection line, there should be a point,
E-
like you said before.
every k over n, isn't it?
No, it's g over n, right?
Wait, what? What's
Wait,
d?
no, never mind. Okay, I might be just bad. Let me think that. Hmm.
Okay, isn't it sufficient to prove that the diameter is greater than or equal to, or just greater than, I guess, c times n over cube root n?
So, n to the 2 on 3?
Yes.
Yeah.
Right, so...
Well, then what's the diameter at least going to be as well? It's going to be at least like your
Well, it can be anything, right? The diameter...
constant. I mean, it'll be like some constant though times n, right? It'll be dependent on n, right? But also, like, wait, no, never mind. Yeah. Continue. Might be just bad.
So if this was true, then d over n would be greater than this thing, which would mean that we could put a line through, right?
Yeah.
There's technically a factor of half involved too, but let's ignore that.
Yeah. That's you can ignore it.
D over n. And also it's technically n minus 1, I think. But let's ignore that too.
Yeah. Yeah, just
And this would work, right? So if this was true, then there would exist such a line, right?
yeah.
Okay, so indeed, this is what we need to prove. So yeah, why is it n to the 2/3? Wait, this is just n to the 2/3.
It seems like just as hard. What, is there a cube root?
Yeah, no idea, right?
Yeah. Wait, I mean distances in 2D are like you get square roots and stuff,
Yes,
right?
but why's the cube? Where's the cube root, right?
Yeah.
I mean, isn't it technically strong?
Okay,
Isn't it technically weaker?
Let's look in L3.
Sorry.
Let's create a new metric. Cube root of a1 cubed plus x cubed plus y cubed. There's your distance formula. New metric. That totally insta kills this question, right?
Is that even
Bible? No.
Yeah, is that even a legit metric? Does it
Does it
satisfy
not follow
triangle?
triangle?
I don't know. Does it?
Should. Yeah, it should.
Okay, yeah, maybe it does.
That is okay. We're getting sidetracked, anyways.
Yeah. So, like, I feel like this might not be true because there are so many other lines. Right now, we're just considering lines of one particular
Orientation.
Yeah, exactly. So the diameter, it should be... Oh, wait. The diameter should be square root n, right? Should be proportional to square root n.
Wait.
Because area
N?
area increases.
Wouldn't it be proportional to N in worst case scenario? Just like having more collinear.
No. We're considering the best. Well, the worst case scenario for us is like when the diameter is as small as possible, right?
Yeah.
And that's the case when like all the points are kind of like inside a circle, like they approximate a circle.
Okay.
right? And when it does that,
Well,
it should
approximate the
be.
interior of a circle, right?
Sorry.
Approximate the interior of a circle, just a
Yes.
circle.
No, in the interior.
Okay, yeah. So it'd be like z squared, like a circle in z squared.
Yeah, exactly. And because the circle's area is proportional to the diameter squared,
Yeah,
then
squared.
and also the number of points is proportional to the area, right?
Yeah.
So then the diameter should be proportional to the square root of the number, which is c n to the half, which is not it's not strong enough, right?
No.
Exactly. So
Is that one mark?
maybe, yeah, maybe that's the one mark.
Yeah, there's one mark. Yes.
Okay, so now we need to consider why it's 2/3.
Okay, so like, yeah. So let me just do a thing I was doing. So suppose minimum distance is like k, because d is like diameter.
Okay.
Then like, if you have like diameter equals d, then there must be like what d over k points between along the diameter.
What's the min distance?
Like minimum distance like from the line to a point.
Oh, right. Yeah, sure.
It's like there's like d over k points, right?
Yes.
Yeah, it has to be. Um, well, at least d over k points.
Yeah.
Yeah. Um, What else can I do? So like that means like this is n is greater than or equal to n d over k. Yeah.
Okay, sure.
Yeah.
Yes, yeah.
I'm just trying to do. Well, I'm not. I'm just doing stuff. I'm not sure if it'll go anywhere. I'll see what happens. I'm thinking. Well, I mean, they're all in the circle as well. So there's like an upper bound,
They're all on the
right?
circle? What is?
They're all in the circle, right? They're
What
all in
is?
that the diameter. Therefore, you can construct a circle around it.
Yeah.
Yeah, like a circle. Wait, it wouldn't be the circle with the diameter. It'd be a circle with the radius. Never mind. Would that wait? Does that work still? Like, wait, no, never mind. I'm not sure if that works. Because you could still totally have like points like outside this circle, right? And that'd still be like less distance.
Yeah.
Yeah, okay, never mind. That doesn't work.
Wait. I'm thinking. So basically, how do we use the fact that? How do we like use line orientation to increase the exponent from half to 2/3?
Well, I think that's where we have to use the arbitrary orientations again.
Yeah. Well,
Right.
that's yeah. My question is like, how do we use the arbitrary orientation
Well,
to increase
well,
from
isn't
half
that
to
where
2/3?
we use my thing maybe the smallest bounding circle instead?
I mean, sure. I mean, like that's just the same as considering
Yeah,
arbitrary orientation, right?
because if you look at that, then the diameter of your the diameter length is less than or equal to twice the radius, like the diameter of the circle.
Yeah.
Yeah. So that puts an upper bound on n as well. Like this would be like less than or equal to like big D over something, right? Wait, let me think about this. Does it even work? Yeah, be like, let's think of big D over K, right?
Wait, what's big D?
The diameter of your smallest bounding circle.
What's small d then?
Diameter of your convex hull.
Right, yes.
Yeah. It's like this, right? Wait, is this true? Well, it has to be, right? It has to be true. Because the diameter, like, the big diameter should not change. Yeah, that makes sense.
Hang on, let me think. Wait, why do we even have an upper bound?
Okay, so if you consider the smallest bounding circle, right, and it has
Yeah.
diameter big D,
Yep.
then every projection will lie on the diameter. It will lie within the inside of the diameter.
Yeah.
Yeah, it won't ever go outside the circle because
Yeah.
of semicircle theorem. So that's why you have the upper bound, because
Because of what
the
theorem?
minimum
Sorry?
distance is K.
Because of what theorem?
You consider a circle, right, and you
Yeah.
consider like a diameter on it. Then for any point inside it,
Yeah.
right, the projection will always lie on that.
Yeah, sure, okay. Is that
It
called
will never go
semicircle theorem or
outside.
something?
Yeah, it can't ever go outside.
Is that like a known theorem or something?
Well, is it not?
What?
Well, it's not even semicircle theorem. What am I talking about? No, it's just like from the
Yeah,
fact of the
course.
circle.
Of course, yeah.
Sorry, my bad. Yeah, but yeah,
Okay.
this gives you an upper bound, right? Because that means your maximum distance between 2 points can't be like bigger than D, which means that like if you put down K, if you have distance is K, then your thing is D over K, like n is at most D over K, right? Because if you have more than that, then it'll have to go outside the circle.
What?
Okay, so if this is D, and you consider like segments of length K, right?
Yeah.
Okay, so there's U over K segments.
Yeah.
Then if n is more than this, then by pigeonhole there must exist either 2 in the same segment.
That doesn't
But
matter.
that contradicts minimum distance is K, right?
No, minimum distance is between lines and point, right?
Yeah, so that means that the distance between 2 points can't be more than K. Can't be less than K,
But
sorry.
This is the projection. So you might have a point that's over here and a point that's over here, and they're projected really close together, but they're not very close together at all.
Yeah, but but within like this thing, you can't have like wait. Even then, like you can't have a line like passing through there, right? Between them.
You mean that's perpendicular, like this?
Yeah.
Sure, but I don't see why the upper bound. Like why do we even have an upper bound? Shouldn't we just be caring about the wait?
Well, if the upper bound doesn't matter, then whatever. But
Wait.
does it upper bound? I think it does. Doesn't it? Either I'm misunderstanding significantly.
Oh right. Wait, no. Yeah, so the upper bound matters. The lower bound doesn't matter, right?
Oh, okay.
Because we're supposed to prove D is greater than N.
Yeah.
Yeah.
Well, is this true or not?
Okay, so let's see. Wait, I don't see
So
why this would be true.
Okay, for any line, okay, suppose over all lines L, the minimum distance is K, right? And it occurs with this diameter.
Okay, sure.
Yeah. Then that means that then we have this true. Like if you project, like if the line is perpendicular to this diameter,
Yeah.
then is this upper bound true?
No, I don't think so, because you can have loads of points over here, right? And then just none of the points over here, and just draw the line over here.
Okay. Wait. Why is that bad? But then, wait, if you have loads of points there, then, like, doesn't that not intersect? As you choose another point there. Oh, okay, yeah. Was it? I feel like this is on the right track, though. Surely. I don't know.
I don't actually see how your idea is different, like, from just considering all the orientations.
Yeah. No. How else can you do this? Why is Q6 so hard?
I don't really like this problem style either, but okay.
It's so much easier. You could actually do stuff.
Yeah. Yeah, what is this? What is this to the power of 2 over 3? Yeah, we shouldn't actually say diameter is greater than this, by the way. It's just diameter is proportional to,
Oh, yeah. Fortunately, yeah.
screw it in, but we currently need it to do, and this, I don't think this is even D, actually. Because diameter, hang on. Oh, right, yeah, so basically, if you consider the diameter and the diameter doesn't work, then we can deduce stuff about the other points. So this one, right? If it doesn't work,
Oh, that one. Okay.
then we know that we can deduce a lot of stuff about the other points.
Yeah.
Let's see. So okay, hang on. So if k is the minimum distance, then we're supposed to prove something like k is proportional to into the 2 over 3, right?
Yeah.
Is that what we're supposed to prove?
Yeah, I think so.
and then we can move
Wait,
the powers around.
wait, isn't that 1 over k?
Oh, wait, oh, right.
Yeah.
And it's also a 1
Do you want
over
me to
3,
change
right?
the distance to 1 over k? Or
Sorry?
do you want me to change the minimum distance to 1 over k? I think that makes it less divisions anyways.
No, just, I think leave it at k, leave it at k.
Okay.
Wait, hang on. So, oh, right. It's because we know that, like, diameter equals k times n. So we know that.
Yeah.
Yeah. Okay.
Well, it's proportional to k times n.
Yes. But otherwise, yeah, we have to deal with this, and this is annoying.
Still trying
So
to figure out
let's
how I can
cube both
keep
sides, right? So
Hmm?
if you cube both sides, it's k cubed is proportional to 1 over n. I think that's easier to work with.
Okay. Or okay, sure. I mean, we just technically reworded the question a little.
Yes, but yeah, I mean, in the previous thing, I didn't really understand. Like, I feel like this is more intuitive to work with.
Okay, sure.
K cubed proportional to
Wait,
1
no,
over n.
it's my bad. Okay, I figured it out. I messed this up. This should be a lower bound as well, right?
What should be?
This thing is a lower bound. It should be at least big D over K, right?
Oh,
That makes sense. I flipped the sign. Yeah.
okay. So why is this?
Just the same thing as I was saying before, except do it properly.
Okay. Oh yes.
Because
Okay.
otherwise there exists a gap that's bigger, right?
Yes. I see that. Yes.
Yeah. I mean, this is slightly stronger.
Wait.
Does it really matter though? I don't think it does. It might not. It's like this is like greater than equal to D over K. This is the case though. Hmm.
But d
Okay, now
d also is proportional to n to the half, right?
Hmm?
Big D is also proportional to n
Yeah.
to the half.
I think. Wait, is it
Um.
the minimum bounding circle of a? Yeah, it should be.
Yeah. So I
Yeah.
don't think it improves the like proportional thing.
No, it doesn't. Okay, but what's a good thing we have about minimum bounding circle? Let's think. Because I still like the idea of it. Because it's the only idea I have for it. There's literally nothing else I can think of for it. Wait, is there always yeah? There has to be a point on the circumference, right?
There has to be 2 points. In fact, there has to be 3. No, wait, never mind.
Yeah. Wait, no,
It's
convex
2.
hull, right?
It's 2. There has to be at least 2
I
points.
Yep. Because you can have it obtuse or whatever. That's bad. So there's 2 points on the circumference.
I mean, if it's 2, then the diameter of the convex hull equals diameter of the circle. But if it's 3, then it's bigger.
Yeah. But can we do something nice with... Okay, so now that we have points that are like a given distance away, though, let me draw a diagram of it. What would it look like, kind of? Let me go on the next slide, because this is just like
Yeah.
kind of. Okay, so let's see. Let's go circle. Oh, that's a bad circle. Let me grab that out a bit. Finish this off. Better. Okay. So I can just say like, let this be the center or something, and then like, this be a point on it. Then like, what do we have? Draw this line. And then, what do we have from here? Yeah, like another point on it. It's either at the diameter or you have 2 points. Oh, I'll be right back. Alright, back. What's happened?
So
Did you solve the question?
yes, I solved the question. So
Or...
I was thinking, can we figure out the hang on. Okay. How about we consider the bounding rectangle where one of the lengths of the rectangle is the diameter. So
why?
Instead of considering all the orientations, we only consider 2 orientations.
Okay, but why?
Because, well, I mean, it's easy to work with, right?
Okay, sure.
I mean, that's just an idea. So
Yeah.
because, like, if you have the diameter, we can also take like the perpendicular line and project everything onto that.
Wait, so you said before that the number of points is like on the diameter would be like proportional to square root of diameter, right?
Uh,
Or was it the other way around?
Diameter is proportional to square root of number of points.
Yeah, right. Okay.
And by the way,
Yeah,
this is
but
the smallest diameter.
yeah. Well, I mean, how about this bounding circle diameter? Wouldn't it be similar?
Yes, it would be. It's the same, right?
Yeah, it should be the same. Hmm. So the number of points is proportional to like the distance, though, on the segment. Yeah. Wait. No,
Yes,
it's like
yes.
O1 over K. It'll be like O1 over K, right?
What would be?
N is proportional to O1 over K.
Well,
It's like 1 O1 over
that just means n is proportional to 1 over k, right? Let
N
me
is O
think.
over K, yeah.
Um,
So you really need like O1 over K is like. I'm trying back solve now. We want O1 over K, like, to be like, I don't know, greater than equal to, wait, is it greater than equal to? What is it? Um, what we have over here, it's, greater than that. Never mind. I'm just gonna keep thinking about this for a bit.
okay.
Yeah.
Okay. Here is another idea. So I'm trying to think about where that cube comes from. What about this? Actually, I think this idea seems promising. So, should we go to page 6? Or should we just use page 5?
That's right. Just use page 5. 'Cause I haven't done anything on it.
Okay, I'm just gonna rub this out then.
Okay.
So you know how all the points are just spaced 1 apart?
Yeah.
And you know how if we have an equilateral triangle tiling, it uses
Yeah.
three distinct. Oh, it's gonna be hard to draw, but it has 3 distinct directions of lines.
Yeah.
And it also plays well with the condition of
Like distance 1, social
yes,
distancing.
yes, and we have n cubed lines,
Okay.
and the area is roughly n squared,
Ooh.
right?
See, I found it. I think I found another n cube root n as well thing, but it's a backsolve kind of thing, so I'm not even sure if it works.
So if we consider these 3 directions of lines, maybe we can get some kind of n cubed thing going.
Yeah. Maybe. Wait, look back at slide 4 real quick.
Yep.
Okay. So you know how for my thing you have the diameter of the circle is like O and K basically. No, it's like greater than equal, is like less than equal to O and K. Yeah.
Okay.
From this.
Right.
Okay.
Yeah.
So then if we can combine these two results somehow, like if we can get like this like square root D, like if we get like this is square root D here or something, like proportional to square root D or something, then you can get a cube root of K. And square root diameter I think does come up in circles when you do like power of point and all that.
Okay.
But yeah.
Okay. Yeah.
So it might be a back solve root. I don't know. Your thing probably is more solid.
I don't know. Yeah, I'm gonna think about my thing.
Yeah.
Um.
I too will think of your thing.
Okay.
Wait, but how would perpendicular distances work on this?
So like, you take any point, and you calculate the perpendicular distance to one of the 3 lines, right?
Mm-hmm.
Oh, and okay. Wait. So we construct these equilateral triangles such that any point can only invalidate. Oh wait, hang on. No, that's not possible, is it? Yeah, okay, never mind. That doesn't quite work, but like, okay, so let's say that like the distance, the side length of all the equilateral triangles is half.
Mm-hmm.
So then, given any point, let's say a point is here, then the closest point has to be outside this triangle. Sorry, this circle.
Yeah. You need a much bigger triangular grid.
Yeah. Okay, so let me think. Yeah, so supposing that the points are arranged in a roughly circular shape with length n, let's say it's n, right? Then we can get how many of these lines? Well, we can get quite a lot of them. So that would be 2n per... Wait, hang on. Oh wait, what am I thinking? It's... Oh, it's 3n. Well, it would be 6n, right? Wait, what am I
Wait.
thinking? Ah. Um... Right, so we place the lines at some distance apart so that any point can only invalidate one line of each direction.
Yeah.
Yeah, wait, never mind. This isn't n cubed. Why did I think this was n cubed? This is just 3n. It's
Yeah.
not even good.
I just realized. Wait. Okay. Back to the drawing board.
I don't know, maybe, yeah.
Back to the gym board. So currently the only possible method of getting a cube root is with the thing I spotted. That goes O1 over K though. What would measure O1 over K? It's like within a fixed distance, the number of points, right? Yeah.
Yeah.
Okay, good. So what's in a fixed distance? Oh, we have a fixed distance of 1, right? Okay. So that means like the line separates by at least like there's at least a half distance. Almost a half distance, sorry. Can we think about this? I want to get back into the bounding circle and see what we can do. So you have that there exists a diameter thing, and there exists a point on it. Okay. Because there's like points along this when you project downwards and all that. So I'll just put some random points here. Okay. Yeah. Yeah.
Wait, we still haven't used the idea from the beginning where we have to have specific angles at the
Oh right,
convex
we
hull.
haven't.
Because that would allow us to calculate like the minimum area of the convex hull. And also that also means the convex hull has to be pretty circular. Because if you have like a
Yeah.
pointy convex hull, then you just cut off the pointy corner.
Exactly. Okay. And that kind of ties in well with my bounding circle idea.
Yeah.
Yeah. Because now what? You have basically the thing actually approximates a circle, basically. The set of points.
Yes. Well, I mean, you know,
Otherwise,
it can still be it can still not be a circle, but then it would be like it would have to be bigger.
Yeah.
Because we know each of the side lengths of the convex hull is at least 1, and the angle is like pretty obtuse.
Yeah.
Okay, let's try this. Okay, I can actually calculate some stuff, I guess.
Wow, we've spent more than an hour on this question.
Yeah.
First time in the IMO.
Oh.
Oh right, I just remembered where you get square root diameter from. Where you can get it from. It's the length of have you seen the geometric proof of AMGM?
All right, yeah.
Yeah. Perpendicular chord
Yeah.
to diameter. That seems really similar to our current configuration, doesn't it?
All right, yeah.
It does. I don't know if it helps, but it looks awfully similar. Like if you did like a random thing like that,
Which
and that's
page are
gonna be
you
like
on? 6, right. Okay,
this
yeah, sure.
length
Yeah.
is gonna be like square root D, like O square root D or something.
Okay, sure.
Does this help at all? Like if you have points distributed in like along like in this region maybe, then because of social distancing, they'd be like proportional to square root D, right? Oh, it should be big D, my bad. Yeah.
Wait, what? Sorry, what? Say that again.
If you have points distributed
Yeah.
along in this region,
Okay.
it must be proportional to O square root D, right? Because of the chord length is square root D,
Oh.
and since the distances is the y coordinate distances should be like sufficient. Like you just make this like length, I don't know, like a half, because then the y coordinate distances has to be like actually like.
No, but doesn't it only work if you have like a square?
I, is this still not true? It's still like O square root D, right?
I mean, um, it would be less than. Oh, wait.
Well, you have an upper bound of O square root D, right?
Wait. For the geometric thing, this is supposed to be like D and 1, and this is like square root D or something, right?
Hmm.
So if this is
Well,
D and this
the
is
length of the
1,
total chord, yeah, it's still yeah.
then the height of this guy is square root D.
Yeah, no, I'm doing square root D for the entire chord length. So make it a half.
Oh,
Make
right,
the
right,
entire.
right, right. I see.
Yeah. Because then you can actually like, otherwise you get like some constant factor stuff shenanigans going on.
I mean, it's not. Wait, no, you can't make it a half to get the chord length equals square root D.
No, it's not exactly square root D, but it's like close enough.
Is it? I
Well,
mean,
let's do the math.
only if it's
D
close. Only if it's really
over
close
2
to the edge.
minus 1 over 2. Yeah, well, D make it D big. I don't know. D minus 1 and 2, and the distance is what?
Sure. Okay.
It'll be like D squared and 4 minus D squared plus 2. Say minus there. 2D minus 1, right? Which is like um square root of 2D minus 1 over 4. That's basically square root D times some constant factor.
Sure. Yeah. For large enough
Okay.
data.
Yeah. What else do we have? It's a half, so that means like you don't have like the distribution of points along here is like gonna be like 1 over k, right? Proportional to 1 over k.
Uh.
Yeah, it has to be, right?
Wait. K is the smallest distance between two
Yeah.
points, or like after the
Between the
projection,
line.
right?
Yeah.
Wait, what? Wait, what?
Hmm?
What's your claim?
That the distribution of points, like horizontally, right, will be proportional to over 1 over k. Right?
Uh. isn't that just for any? Like that's for any chord,
No,
right?
just like along this thing, right? Along
Which
this
thing?
thing, length 1/2.
You're projecting it onto the half.
Yeah. Well, you just consider points inside this region, right?
Okay.
Because the points are already proportional to square root d, number of points there.
Okay.
And if you project it onto there, it's like proportional to like the you get number of points proportional to like 1/k, at least. So it's like you get like a lower and upper bound, right?
Do
I don't know.
you?
I can't
mean,
tell if I'm just messing around and just messed up my logic again, like I did last time.
I mean, you got some area, and from that area, you can determine how many points are in it. Like
Yeah.
there's an upper bound on the number of points in it.
I mean, that's what square root d is, right? It's the upper bound.
For the it's square root d is the upper bound for like it's the proportional to the upper bound of the number of points in the region.
Yeah.
Okay, yeah.
Yeah.
So that's also sure. Okay. I mean,
But you also have like
I
lower
don't know.
bound, right?
Uh, uh, I mean, how would this help though?
Because you get an upper and lower bound, and you already have an identity
Wait,
relating them
what's the lower
before.
bound?
Like 1/k, right?
What's the upper bound? What is it? Don't we only get an upper bound for the number of points in the region?
You get the upper bound on the total on the number of points from the air this vertical thing, but from the horizontal thing you get a lower bound. I think. Oh yeah, they were messed up again.
I don't think you get a lower bound. Like you can't get one of the bounds by considering. Like I'm not sure if it's the upper one or the lower one, but like I'm pretty sure you can't just get both bounds by considering the same idea.
Yeah, probably not. Okay, well, I mean, you got a good square root d number of points in that region, and it's like if that's proportion. Wait, I keep thinking.
And shouldn't it really be proportional to d because it's area, right?
No. Again, like I'm looking at only the distances in the y coordinates. Because look at the x coordinate distance; it's like at most a half.
Yeah, sure.
It like makes it super tiny. You can't really have points along like spread out horizontally. It's only vertically you can have points.
Half. Oh yeah. Okay, yeah, I see.
Yeah. Like you'll have slight variation like your x
Yeah.
coordinate, but like the y coordinate's the main thing that are changing,
Right. Okay. Yep. Sure.
which is why it's close to square root d.
Yep.
Like you'd have to realize that and stuff, but like the 1/2, pretty much like yeah, because basically like a really long sliver.
Yeah, but I still don't see why does this help?
I don't know if it does help or not, but the point is it gets a square root
Right.
d, which is what I want.
Okay. Okay.
From the back solving thing, you know that back solving thing. That's what I want.
Okay.
We have like d is like proportional to like n times k. Yeah.
Sure. Okay.
Yeah. So your point distribution along that sliver is at most square root d, like just by social distancing. But what else do we have? It's like if you project it along onto that, then the point distribution is at least 1/k. Because like just like last time, the goddamn d/k thing, right? Where if you distribute points onto the line, you get a lower bound, right?
For the number of points.
On the remember
Yeah.
the
Sure.
number of points along the line. We said that using this projection thing, we get its d/k
Yeah.
as the lower bound.
Yes.
Just to do the exact same thing, but this time your d is like a half.
Okay. Sure.
So therefore your lower bound's like O1/k, and your upper bound's like O square root d.
Well, that's only considering that you have any points in that segment at all, right? Otherwise, you can't even draw a line that passes through there without.
Well, there exists at least one point because I chose this point here to be like the point that's guaranteed to be in the circle,
Okay, sure, okay.
and then like you just consider like all the points are in there. Wait, does that still work?
But I feel like this is basically the same.
The lower bound thing it guarantees there has to be points in there. Yeah. Otherwise, your line's pretty bad.
Like, otherwise you can just draw this line, right?
Exactly.
And it's just a quarter. Sure. I mean, but like, I feel like this is just the same. Like, if you're considering this, you might as well consider like the angle instead.
Wait, but if it already works, then we don't need to consider angle, right?
No. As in like,
because you got a lower bound and an upper bound.
So let's have a like a more accurate diagram, I guess. Let's say we have like this arc here, and I don't know. We can have like this line, right?
Mm-hmm.
So now you can have like, so the distance 1. Okay, so you can have like, stuff like this.
Two, right?
Right?
Yeah.
Yeah. I mean, just repeat this, right?
Okay. You still can screw D points in there.
Sure, but you can have. I don't like what. Sure. Okay.
You get the upper bound, but you also get a lower bound from like the logic from before.
Sure, but we only need one of the bounds, right?
Okay, let's just see what happens with this logic. So we have
Okay,
like
sure.
square root D is like what? It's gonna be less than or equal to like Cn on K or something. No, is it Cn on K? Or is it like no wait. What is it? Let me think. It's like CK, right? Yeah, CK. C over K. So it's like D is like less than or equal to C on K squared. Right?
Mm-hmm.
But we have like D's like what? Greater. It's like wait, did I mess that up? It's oh crap. D's the upper bound. My bad. Yeah, it's like the other way around. But this is like less than or equal to like NK, right?
Okay.
And then like you get the K cubed.
Okay,
It's
sure.
like K cubed is greater than or equal to C squared on N. Isn't that what we want? I don't know if I've just fake solved it or something.
What?
I don't know.
Wait, what?
Is this not what we want?
I'm so confused. Wait, okay, so hang on. What's square root D over greater than or equal to C over K?
Square root D greater than or equal to C over K. That's from
Yeah.
like this thing here, like this sliver thing. Because remember, C over K, the 1 over K thing is your lower bound, like by the logic from before, and square root D is your upper bound.
Wait.
Okay, should I go through it again?
Yeah. Okay, sure. Yeah.
Yeah, okay. So, okay, I'm just gonna draw below your thing. I'm sorry. Okay, so we know that along a segment, right? If you have a segment of length D,
Yep.
then distribution of points along it will be like O like D over K, right?
So K. Okay. So what's K again? How do you define K?
K is your minimum distance between line and point.
Like across all lines.
Hmm.
Like across every possible line.
Hmm.
Is
For
this...
a segment of length D with like points on it, where you project points onto it, right?
Yeah.
So it's gonna be proportional to that. That's your That's the number of points I'll be
No,
on.
wait, but how are you defining K?
K is the minimum distance between a point and a line across
Yeah.
all the points.
Wait, across
Yeah.
all the no.
A
But
point
is
and
it also
like your
across
line
all the lines?
Yeah.
Right. Okay. Yes. Sure.
Yeah. Like whichever one minimizes, like maximizes your like minimum distance,
Mm-hmm.
right? So it's like you have this is like OD over K. So in particular, when G's a half, this just implies that it's like O1 over K, right?
Sure.
Okay. Now that means that in this sliver, then that the distribution of points along this thing is like O1 over K. Yeah,
Sure.
because it's length a half. But since this sliver is also like height square root D, yeah, your
Okay.
distribution of points along that will be like O square root D, but that's an upper bound, whereas the O1 over K is like the lower bound.
Are
Yeah.
you saying it's because?
Hmm.
Are you saying it's because like? So we have at most this many points inside that sliver.
Yeah, because of like social distancing.
Yep. And
Yep. But we have at least one over O1 over K like points when you project it onto the line, right?
okay. Yeah. Sure.
So that means that it's like square root D is then therefore like greater than or equal to like C over K. Yeah?
Wait. Let me think about this.
Because the O1 over K is your lower bound and square root D is your upper bound. Please find the error, if there is an error.
Wait.
Like it has to be the O1 over K with lower bound. Does that make sense, right? Because if it wasn't a lower bound, that means you could create a line that has even less, that has like a large distance, and that like contradicts its definition.
Okay.
You don't sound convinced.
That's because wait. Wait. 1 over K. It would be. It would technically be half over K, right?
Yes,
Can we just use that instead?
but it's a constant term.
I mean, sure. Okay. I mean, but basically, you're saying that like in this
Sliver.
yeah, there's uh there is 1 over 2K points at most.
Well, proportional to something proportional to that. Yes.
Well, it is at most, right?
Yeah. It is at most. Yeah. Okay. Well, at least you mean.
All right, yeah, at least. So okay, if n is the number of points in here. Oh, wait, no, wait, is that's not good notation. Yeah. If m is the number of points in there,
Yep.
then m is greater than that, right?
Yeah.
Okay, cool, sure.
And M is less than square root D because social distancing. Right? Because you can't really have
yes.
like
I mean, it's
yeah.
yeah. Okay, pretty much, yeah. Okay, so
So
then you have square root d greater than 1 over 2k.
yeah.
Cool. Okay.
So D is like greater than 1 over 2k, 4k squared. Yeah.
Yeah.
Now, with my thing from before, where I proved that n is greater than or equal to big D over K. Remember? Because of the same reasons, like as like in that sliver thing, but except applied to the entire diameter.
So the
N greater than or equal to D over K, because like if you have distance K again, then along that diameter, right, it must be there must be at least D
yeah.
over K points. Yeah.
Yep.
So D is less than or equal to NK.
Hang on. So D over K. So N has to be greater than D over K, right?
Yeah.
Yeah. Okay. So then NK is greater than D. Okay.
Yeah.
Right. So wait. So then from here, you're saying we're done, right?
Yeah. I don't know if I fake
Okay.
solved or not.
Let me think about like the general
Like
argument.
I don't know. I can't tell if I fake solved or not. This is too difficult.
Okay. So D is greater than. Oh, so square root D. This is greater than that. Okay, I'm just gonna draw like a try an example, I guess.
Okay.
So you want this distribution, so you can't draw a line like this, and then this is square root D. Right. Okay. So I feel like the reason this works is exactly the reason. Wait. Okay. So
I think it's along the vein of logic your thing was doing, but
yeah.
it's along the circular segment as opposed to a.
So like, my thing was trying to figure out like, kind of, like the segments. I think, like if you actually drew in the convex hull, right? We can't really draw it in here, but yeah, it would be like we could figure out how many points roughly were on the convex hull. But then your
Yeah.
thing uses the square root D thing with circles, right?
Yeah.
And by using that, we related the diameter to right. Yeah. Okay. So So I think what's happening is like with my original idea about angles, you have to consider. So I was only considering like a single angle, right? And what that has to be. But
Yeah, but you
like
have to do them all. Yeah.
yeah, you have to consider it like further down the line, and where you get to the
Yeah.
root d thing, where this is
Yeah.
half. Right. Yep. Okay.
Okay.
So then this would prove that so square root d is greater than 1 over k. It's proportional to 1 over k. Also, it's like greater than. Yeah, because okay, there kind of has to be 2k
So I mean,
here.
does it work? Like if it works, we get k is like greater than 2 to the minus 2 on 3, n to the minus 1 on 3. Which seems pretty solid.
Right. Yeah. Okay. So we related this chord to the number of points.
Great. You're on slide 8.
Slide 8. Okay. Let's see.
Are you on slide 8
No,
as
no,
in?
no. I'm on
'cause-
slide 6. I'm on slide 6.
Okay. Yeah. Okay. There's a slide 8 open. But I have it on. Okay. Let me try something.
Yeah, yeah. So this, and this.
Maybe that's still constant proportionality, I think, because it's not a square. It's not square root g. It's like square root 2. It's like square root 2g. Or whatever.
So
And of course, it's like c equals 2. Yeah, so if my thing is correct, I think you get c equals 2.
oh, interesting. Okay.
for like large enough n.
Right, yeah.
Wait, sorry, 2 to the is it 2 to the minus 1? So yeah, it's a half. Not bad. I find index law. Yeah, that makes sense.
Like, I'm convinced of the steps, but I still have no intuitive feeling for why this works. So,
Yeah, neither.
yeah. So I don't think it's a fake solve, but I guess we can just write up the solutions. I guess I can figure this out later. And
Yeah, I'm not too sure.
We'll figure out if it's a fake solve during the write up.
Yeah.
Yeah. But I don't
The
really.
steps seem.
Yeah, exactly
Yeah.
right. The steps seem right, but I don't have any intuitive, like, I don't really get why the solution works.
Yeah. Like I only got it from like back solving it basically.
Right. Yeah. Okay. Yeah. Well, how does this work? I have no idea.
Like it just works out like mathematically.
Yeah. Oh, yeah.
Yo, Livesolve chat, did we fake solve?
Hang on.
You know.
Hang on a minute. Here's a question then.
Have they got 1/2 yet? Ishan asks. Oh my god. It's correct.
Wait, is it? Is it 1/2?
Ishan asks, have we got 1/2 for 20 minutes ago?
Oh.
And I just calculated the constant, it is 1/2. Oh, so it's correct.
Wait. So hang on. Wait. Oh, I see. Okay, I think yeah.
I still don't see why it works completely. I just see, oh, look, the maths works out.
Yeah, same. But like, I was wondering why it doesn't work for like even stronger. Like, why can't it be like cube root d greater than c over k or something? But it's because I don't. I think if you do cube root, then it's not a constant anymore. The c isn't a constant.
Ah. So does there exist a configuration of points where it just that's the actual thing then? So it's a quality case?
I have no idea. I don't think this solution sheds any light on that, to be honest.
Exactly.
Yeah.
Oh, like, kind of maybe. Like on the sliver of points, it tells you okay, it should be distributed like a line there. So I'm thinking
Well,
it's like
it tells you that like it tells you similar thing to what like the angle condition would tell you, right? That the shape very closely approximates the circle.
Yeah.
Yeah. But that's just the that's just the outside.
Yeah. But then like if you have a large enough circle, then there'll be like tons of lattice points or tons of points on it. So if you like could you approximate like an integer lattice or something?
Sorry, what?
Approximate the points as like an integer lattice in like z squared. And like you have a circle in it.
It would be like a triangular lattice for like to fit the maximum number of points.
I'd be trying yeah, because of the thing, yeah.
And you would need to like move the points around because you don't want any of the points to be collinear and stuff. I don't know.
Yeah.
Like, yeah, it's messy inside the circle, but I think on the boundary of the circle, it pretty closely approximates an actual circle.
Yeah. Goddamn Q6, what is this? It's a non-constructive proof. But according to Shanghai, correct.
Did he just reply?
No, but he said that like 1/2.
All right. Well, okay. I guess we can start writing up solutions. Do you want to write up problem 3? Because yeah.
Which problem?
You can write up problem 3, I guess, and I'll do problem 1. Sorry,
Okay,
no,
but
4 and 6.
I'll see.
Yeah, yeah.
Yeah.
Oh my god. All right.
I'm just still thinking about what could it look like. Well, this is a pretty short solution, right?
Oh, it is. Yeah. I mean, okay. I guess you have to like. Yeah, there are some like things to iron out, like the
Yeah.
approximation. I guess like for large enough d.
Yeah.
But I guess that can like that can be sorted with limit stuff.
Yeah.
Yeah.
Hmm. Just, all right, whatever. Let's type up. That took us like 2 hours.
Yeah.
But that was definitely more of an IMO than day one, I think.
Yeah. Yeah. Yeah.
Day one saying, Oh yeah, have fun typing a problem 4.
I think. I think problem 4 is fine, to be honest.
Okay, yeah.
It's just yeah. We just like we were just messing around for too long.
Okay, let me go on AOPS
Man,
and like get
man.
the problem statements.
Oh right. Oh, I just typed them out.
It's
But yeah,
hard.
yeah, yeah. Uh, yeah, I can kind of see why this is classified as a geometry problem.
I mean, yeah, I barely didn't combine that really. It was just like,
Yeah, yeah. There's hardly any combi in it.
yeah.
Disappointing. Not a true combi geo. Oh well. I mean, yeah, yeah. So I
It
feel
doesn't
like
pigeonhole. The lower bound you need pigeonhole for basically. Wait, is it pigeonhole or just the other thing?
yes.
No.
Well.
Eh,
Oh yeah, no, it's not
whatever.
pigeonhole. It's just there needs to be one every. Yeah, yeah.
Okay, let's.
I mean, I guess it's kind of
type that.
like continuous version of pigeonhole. I mean, yeah. It's just like average values, right? Yeah.
Yeah, yeah.
Okay, okay. So I think. I mean, both the inequalities make sense. Like I've made sense of both the inequalities, but I guess the single inequality. I feel like that's where the diameter comes in to help, because I can't make
Yeah.
sense of like I can make sense of the first inequality and the second inequality, but when you just remove the D part and just have the two inequalities, then that just doesn't make sense. But I think that's exactly why you need the diameter.
Yeah.
Yeah. So the bounding circle, yeah.
I mean, you can probably modify it to include the convex hull diameter, right? There should be something similar with that.
Um,
Actually, no, it might be a bit weird.
nah, because you need the square root D, and you can't get that unless you have a circle.
Yeah.
Exactly, yeah.
Yeah.
Yeah, but
That's
diameter was definitely good idea. Like
yeah.
the helpful idea, and then the circle to get square root D. That's like the oh man. Okay, this is I don't know.
AMGM put it in.
Oh right. Oh yeah. That's how you like. That's how you're thinking about it, right?
Yeah.
Oh my god.
It's like, where do you get square root diameter from?
Oh my god. I can't believe that's how you solved it. Okay.
Well, Maxwell plus AMGM.
Yeah.
Hey, there were two inequality
Nah, yeah.
questions in this
I reckon.
scenario.
I don't. Yeah, I really don't think I would have tried the square root D idea. Yeah. So.
And I was only doing it because I couldn't think of anything else. It was like,
Yeah.
Maxwell
Well, it
square
just
root
happened to
D.
work, right? So nice, yeah.
Yeah.
Oh man.
Although I kept failing every time I tried something, so yeah. I would have given. I don't know if I'd given up or not.
Well, it's good that you didn't.
Yeah.
Yeah. Man, I actually thought I
Yeah.
had it with that like hexagonal lattice thing until I realized there was actually
Yeah.
3n, not n cubed. That was like devastating.
Yeah.
Like, I was like, hey, it works so well with distance 1, and it's got three different directions, and yeah, it just fails. Really.
Yeah.
Man, okay. Well, that's an interesting experience. I don't know. That may be one of the hardest problems I've done. I feel like I don't know. I mean, technically we did it right, but yeah.
Yeah. I don't know. That was definitely hardest for me because it was combi and geo.
Yeah. Anyway,
Yeah.
let's write out the solutions.
All right.
We want to try and finish before 1, right? I mean, yeah.
Yeah. So maybe the diameter of the small circle containing every point in Mathcal S. Then let K be the maximum value of the minimum distance between L and points in Mathcal S cross all such L. Then it is sufficient to show okay. Equal to Cn to the Okay, I'll be right back.
Okay. Hey, you back?
Wait, how would I explain the that the sliver will only contain will we have like square root two will be square root d like points in it.
I mean, it could technically contain slightly. Wait, could it?
No, it can't. Not really. It's like proportional square root d, right?
Yeah, yeah.
Oh, like, could you just say that you can bound it within a rectangle of like square root d by a half?
Sure. Oh yeah, sure. I think that would work. That would give you like a fixed constant to work with, right? Or like
Yeah,
something nice to work with at least.
yeah.
I think that works. Yeah.
Just wait.
I mean, yeah. All you need is the proportional part. So. Also, I noticed that we actually fake solved problem 4, but I fixed it really easily.
Wait, how do we fake solve it?
I don't know why, but at the end I said that there's like, if you look at the diagram I drew, like the blue cars have like a really long path. I have no idea why I drew that path, but like you just use pigeonhole on the blue paths, so that like
Yeah.
two of the red stations end up in the same blue path, and then you're just done. So, yeah, so it wasn't very hard to fix, but yeah, that's basically.
Right. Okay. Can I just say that square root 2d minus 1 is just approximately square root 2d? And that should be fine.
Yeah, just say for d large enough, it will limit to that, right? Surely, yeah.
Yeah.
Like we can fix the constant c.
Yeah.
Um,
Okay, so if I do it correctly, it'd be like 2d over root 3 if I do it in the rectangle. Like you just like alternate sides, right?
yeah, exactly. Yeah, and that's obviously the best you can do.
Yeah.
By being greedy, yeah.
Yeah. Note that this has the densest packing of points when when of points distance by 1. This one when Okay, yeah, if I do the rectangle thing, makes it thing bit wake up or whatever.
Just a constant, right?
Yeah, it's just a constant.
Right, I should be
yeah.
fine. Yeah.
Yeah, it's cube root of 3 and 4 again instead. Alright, I'm done with that one. Should I have a problem 5 quickly? Because that was easy enough.
Sure, yeah, sure. I'll read your solution for problem 6.
Alright. You read the proof?
I'm still reading it. Did you finish your proof for problem 5?
Almost.
Okay.
Oh, the P divides AK minus 1. Alright, I think I'm done. Yeah.
One thing, by the way. So actually,
Yeah.
in your solution to problem 6, a lot of the time, like, we're implicitly using contradiction, but we haven't mentioned it.
Oh. Okay.
Because, like, we're assuming that it's impossible for some L, right?
Yeah.
Yeah. So I've fixed that up a little. And
Aye.
also, I just realized that technically, they're slightly less than. It can be slightly less than 1/2k points.
Oh yeah, but it's like
It's like 1/2. Uh, I mean, it's something not nice,
yeah.
but I think it's slightly less. But oh well. I mean, it's proportional, I guess. It's close enough. Uh, oh, actually, wait, no. Actually, no. I think you might be right. Yeah. Oh no, it's fine. It's fine. It's fine.
Yeah, it should be
It should be.
basically correct.
No. It is fine because, it's half, and since you already have a point at the one end of the diameter, you can just keep counting k's from there. So the number of points you need is whatever. It's half of a k, right? Exactly. So it works. Yeah, it's fine. It's fine.
Okay.
Um, 2xq equals 2. Right, yeah.
Wow, they both days take up about the same size of solutions.
Oh, interesting.
Yeah. About 2 pages each. Wait, no, never mind. One. Wait, can I not count? Oh no, there's an extra page there.
Oh, okay.
Yeah. 1, 2. 1, 2. Yeah. Okay, we are like 15 minutes.
Yeah.
Yo, Ethan, what up?
Who's this? Oh,
Ethan.
it's 10.
Hmm. Was he gonna flex on us that, oh, we've actually fake solved?
Yeah, rip. That would have been a big rip.
Yeah. Well, you guys know that it doesn't actually work because of this thing.
Cool. Did you read my solution for 4?
Yep, looks fine.
Okay, cool.
Yeah, and 6 looks okay.
Yep. 6 looks good.
Yeah. Like, it makes sense why the density argument in, like, the thing, right? The sliver, rectangle.
Yeah. That works. Although I think we probably lost some. Like, we technically didn't consider. You know, when you did the square root 2d minus 1 approx square root 2d for large enough d.
I mean, I can revert it if you want.
No. As in, like, I feel like that might have had an effect on the constant. I mean, it doesn't, right? But, like, we know our constant is good enough, but, like, we didn't take that into account, if you know what I mean.
When? Like, initially?
Yeah. When you said square root 2d minus 1 is approx square root 2d.
Yeah.
Yeah. That would have had, like, an effect on our constant.
I mean, yeah, of course it.
Yeah.
That's like through, right?
So we should probably, like, say something like, I don't know, the effect on the constant is strictly decreasing or something.
Yeah.
I don't know. I mean, we probably don't need to. It's probably fine.
Fine.
Yeah.
221. What's happening to line 221? Oh. Recompile. There we go.
Wait, why is it in particular if any number is even, then blah blah blah? Isn't that just... Why is that important?
I need to redo the divisibility thing. If p divides ak minus 1 on 2, p divides ak minus 1. I just needed it for divisibility. I don't know.
Wait, do you actually need that?
I thought I did. I didn't
Because
think I did actually.
2 is a prime 2, right? So we can just group it into the thing with the other primes.
Okay.
I mean, I don't know.
I mean, if you don't get rid of it, sure.
I mean, we can't lose marks from it, obviously, but...
Yeah.
Because I don't think we need... Like, the rest of the proof doesn't rely on all the numbers being odd, right? Or does it?
Nah, but it's
Right.
just like, but it's like a half. P divides ak minus 1 plus ak on 2.
Yes.
Yeah, well, if p is even, p is 2. Then you can't say, 2 divides ai minus 1.
Oh.
Yeah. That's what I thought. I mean, technically, you probably don't need it, but I'd have to say something else about it. That, in the case where it's 2, then you observe that, it actually doesn't matter. Because
right.
then the case never happens.
Oh, right.
I'd have to
Sure. I mean,
that.
yeah.
Yeah, that's what... Or is this just avoids it all?
Okay.
Yeah, our constant basically reduced by like a half, which makes sense, I think.
Yeah.
Because rectangles are roughly twice the size.
Cool. Okay, I guess that wraps it up.
Yeah.
Man, oh nice. Okay, so I guess we got at least pretty close to a perfect score, which is pretty good, I guess.
Where would we even...
Yeah.
Where would we not have perfect score? I don't know.
I don't know, like maybe we missed something somewhere. I have no idea. But it would be perfect score minus epsilon,
Yeah.
if anything. If not perfect score.
We got perfect score plus epsilon.
Yeah. Because we came up with our own problem after day 1 and we solved it.
Yeah.
Because we had so much time left.
We had like 7 minutes left over in this day though. So
we
it's
technically
an
have
actual
12.
IMO.
We technically have 12, right?
Oh
We
yeah,
started
true.
at 35. Yeah. Should we look at the comments?
Let's
There are
have a
almost
look.
no comments. Yeah. No.
Livesolve chat. Okay. What's happened? Not much. Rip. Besides, okay, mountain faces, monotonically increase in height. Anything that any AP team reports on to quote on day 2. Accurate drawing when Tony did a 12-degree angle, which is obtuse.
Yeah. Best diagram.
Wow. And you think it'd take us 90 minutes? Do you think we're good at this?
Rip. Isn't day 2 quite a lot harder? Like, I thought day 2 was quite a lot harder than day 1.
Yeah.
Yeah.
Like it took us like 3 times as long, right?
Yeah. And also,
Q4
it took us
harder than Q3.
problem 4. Yeah, took us longer than all of 1, 2, and 3.
Not together, combined,
Yeah,
but like
but
individually.
separately. Yeah.
But okay, if it has to rate the difficulty, it'd be like Q1, then Q5. I think they'd be probably about the same actually. Then be Q2, Q3, Q4, and Q6. Yeah.
Yeah, fair enough. I mean, Q4. I feel like Q4 isn't. It wouldn't be rated as very hard. I don't know why. We just messed around with it. I feel like it isn't actually very hard, to be honest. I feel like it's probably
got confused.
But yeah. We just I don't know what we were doing, to be honest.
Yeah, we're warming up.
Yeah, exactly. Yeah. All right. Well,
But Q3 was much nicer than Q4.
I don't know. I thought Q4 was pretty nice. Although Q3 is it's very nice. Yeah, I agree. But like I think I liked Q4.
I didn't.
Oh, okay.
I like Q3. I didn't like Q4.
Okay. Fair
And
enough.
Q6, I have no idea on Q6 because I still don't have the intuition for
Yeah,
it.
same. Yeah.
It's like, okay, cool. What now?
Yeah. I mean, actually, I feel
So,
like So, okay, I was thinking about this. The intuition for Q6, I feel like, is related to the fact that, like we said, the diameter, you can use the diameter to bound, in one way, right? Like kn greater than diameter.
yeah.
Okay. That just comes from the fact that
There must be a minimum distance away.
yeah,
Like
yeah,
from the
exactly.
line. But the upper band comes from the social distance.
Yes. The other bound comes from the fact that if we try to... So basically we need at the very edge of the diameter, consider the maximum height. Right? So for a fixed edge, the height, it's a bit like if you have like a bounding, it's almost like a bounding rectangle.
Yeah.
Yeah. And once you get that rectangle, then you just, because social distancing. I love how we're calling it social distancing.
Yeah. What else is it?
Yeah.
It's like the best way you say it. Like,
Yeah.
the minimum distance. Just say social distancing. It is literally social distancing. Let me check an AOPS if that's like the actual thing they base it off. Surely, like it's got to be. Interesting story behind this problem. The story was okay. 14-day quarantine in Taiwan.
Oh, it actually was?
Uh,
Do you
so
have the
there got to
link?
be a pandemic going on when you quarantine someone. That probably has to be social distancing measure imposed. I suppose each point is at least 1 unit of it away. And then, okay, he did his machine learning assignment on support vector machine.
Wait, can you send me the
And
link to this?
it's on the AOPS. It's like on the AOPS though.
Okay, let me just search this up then.
Um, there is your link.
Oh, thanks.
I'm definitely not surprised. I was just thinking, yeah, this is definitely topical. Yeah, so they got initially alpha equals the other thing equals to a half, which is what you got.
Sorry, what is? Oh, right, yeah.
Yeah, using the diameter argument. And if you did a randomized construction, then you get a half as well, like randomly for like lines, but you could improve it. There is still a log n gap. Okay. Yeah, 2014 P6. Yeah. So the guy who did was IMO 2014 and he didn't get that P6, so that's why. Oh, so the original wording is like actual social distancing measure.
Oh, really? Oh, wow, okay.
N grade included 2 points on a plane, each representing a person. Due to an ongoing pandemic, they are required to adhere to the social distancing measures posed by the government. In particular, the
Where
distance
is
between each
this?
pair of points required to be at least 1.
Where is this?
But to further control this is in the app thread I sent.
No,
This is
which
the,
post? Which
like,
post?
number 3.
Oh, is it? Oh, okay, I must have missed it. Wait, what? Oh, original
further
statement. I
control
see it. Yeah. That
the
original statement. Yeah.
The government decides to build a long wall represented by a straight line on the plane to separate the people into non-empty groups. In order to make sure the two groups are separated as far as possible, the government hopes to maximize D, the minimum distance of a person to the wall. Show there exists a positive constant C, so that no matter how the people are distributed, so long as the distances between them are still at least 1, the wall can always be built so that D greater equals C into negative a half.
Oh, interesting. So yeah,
So there's a half. That's
originally, yeah. But a half is easy, right? Like we got half, like
yeah, so that's in a
yeah.
Q2 or something. So I think they just improved it and they go, let's make it Q3, Q6.
Wait, they showed that a third is optimal. Interesting.
Yeah, that's interesting. Has anyone got a diagram of construction by any chance? Okay, someone got a solution for alpha equals 1. That is a bit of a...
Yeah. Well, yeah. See, some people said like, the proposal of the problem says he has no idea why this problem is a G.
Oh, okay.
He's like, one possible reason is that the problem selection committee wanted to have more than 2 combinatorics problems. Yeah, oh man, so many memes in here. Gradually, the IMO is redesigned to become an IQ test.
There have been a few people who are complaining about the increasing number of C questions.
Yeah.
It's still,
I don't know.
It's still G. There's so much G in this.
Yeah, there was. Although, I mean, there were some
There's combinatorial
yeah, there are ideas. Yeah, it's definitely not your typical, Euclidean geo problem. With angles
it's
and
non-standard
lengths.
geometry.
Yeah, exactly. I don't know. I mean, personally, I would be pretty fine with the IMO having more combi problems.
I mean, don't think too much because I'm not in it. You can't touch this.
Yeah.
Okay, so some guy got the C value as about 0.1486. What's our C value? It's like, what's cubic 3 and 4 going to be?
Sorry, what did people say?
So apparently you can get C above 0.1486. They've got, apparently.
Oh.
Someone's got it. And our thing is like 0.36. Okay, never mind. Ours is stronger.
Isn't the actual
Because
constant is half, right?
is it?
Isn't that what Ishan said?
I don't know.
I don't
if
know.
that's
Is he
like,
trolling?
I can't. I haven't seen one. Oh, apparently you can get log n as well. Log n factor into it.
Oh, okay, interesting.
Yeah. So n to the -1 3 log n, or like over log n or something like. Okay. Yeah, so apparently probabilistic method gets you 1/2.
That's just the same thing we did, right? So like you just consider, area grows by square, and then yeah.
Exactly. Whereas the random thing, this random sliver thing works.
Yeah.
Oh well, I think that's
Also, I don't know why
about it.
people. To be honest, I don't know why people are saying problem 5 is combi. I highly disagree.
That was not.
Yeah, it was
What the
not
hell?
combi at all.
There was like 0 combi in that.
Yeah, I don't know why people thought that was combi.
Yeah. Can people explain why they think it's combi if they do think so? Because it does not look like combi.
Yeah.
Like maybe the wrong setup made you think, oh, this is combi as well. But if you haven't actually tried the question, I mean, like, of course you can say that.
I mean, wow, it has cards in it. It's combi.
Yeah. Well, there wasn't even any like combinatorial like things involved, right? in
Yeah,
that
not
solution.
really, not really. It's just like, AMGM kind of thing, and then, some induction. I don't know.
Not
There's
even
no
an
combi in it.
AMG kind of thing. It was just like, oh yeah, this is big and it's bigger than this, so it must involve this thing.
I
And it just
mean,
go down. It's more algebra than
yeah.
like
Yeah,
combi.
there's more algebra than combi. Yeah, exactly.
Yeah. And it's not even algebra, it's number theory.
Exactly, yeah.
Like maybe the setup was like, oh, it looks a bit combi like, but come on, it's Russia. They're gonna think it kind of combi.
Yeah. All right, well, man, yeah.
But like it's, yeah, that was fun.
I mean, I know Russia, like, how, I think, not quite sure, like, about the time period. I think this was, like, I was, like, 20th century anyway. But then, like, Russia had those coffin problems.
Yep.
Yeah.
Done a few.
And a lot of those were, like, non-standard geometry or, like, combi and that kind of thing.
Yeah.
They had a lot of, like, tetrahedron problems.
Yeah.
Yeah, if you look through, oh, man. So I can kind of see where the whole Russia-style problems comes from.
Apparently, people are saying because it was invariance in question 5 is combi.
Invariance?
Because P divides all the terms.
It's
an invariant.
That's not... Wait, is that... Can you even call that an invariant? How's that even an invariant?
It doesn't change.
What? But then, like, everything is invariant. I mean, like... I don't know. That's not like that's not a normal invariant. The normal invariant is like you have some property about the system, and then as the system changes, that property is invariant, right? But the system doesn't change in this thing.
Yeah.
Yeah. So I don't know. Yeah. Anyway, I guess we should wrap it up. I don't know. Do you want to look at the forums for the other problems, or?
Well, the other problems like that. Do you want to look at? I don't know. We looked at Q1, Q2, and Q3, right?
Not on.
We still have. Okay, let's look
we
at
looked
Q1
at this.
first.
We looked at the solutions, the official solutions.
All right, yeah. Let's look at Q1.
Q1.
What's happened? Okay, apparently it's European geometry. I mean, it makes sense. It is European geometry, in my opinion, because American geometry is all those configuration-based stuff.
Hang on a minute. All right, yeah.
Like, have you noticed the difference between European and American geometry?
No, not at all. But I haven't.
European geometry is literally like it's weird. It's kind of weirder questions, whereas American geometry is configuration-based.
Oh, okay.
Like
Interesting.
advanced contest Q2, that's like American geometry style. Because like it's got your for the perpendicular from like D to EF, where the D, E, F are touch points and stuff.
Why are people saying this problem is bad?
It seemed artificial, I guess, apparent for some people, and like it was easy once you figured out how the angle condition worked.
It was easy, but like
It's non-standard.
yeah.
If you only practice Euclidean geometry, but if you only practice like configuration-based geometry, you don't actually have any intuition, like creativity for it. Like it's not gonna help.
Yeah,
You may struggle with it.
I like the problem. I don't know. Maybe I don't know. Yeah.
Like because like constructing that is like non-trivial. Like to actually realize that you can construct that isn't easy to realize. It takes like experience, I'd say.
Yeah, I guess. Yeah. Yeah, some people are like hardest problem by far. The hardest part of the problem was getting the diagram right. Yeah, we just didn't get the diagram right. So I guess we skipped that whole point. Yep. Great.
I mean, we still aim for a bit of like accuracy, just not completely accurate.
Okay, so I think
just enough that like.
I wonder. Wait, what were the stats for this year's IMO? Let's have a look at that. Actually, I'm curious.
Oh yeah.
We haven't looked at that.
So we came first with 42.
Sorry?
We came equal first with 42.
Yep, exactly. And then...
Yeah.
So it's 20. Stats. Let's have a look. Or in fact, I think... I wonder if this website has updated. 20. Yes, they have. You can have a look at this website.
Okay, so P1 problem 1 statistics: 117 zeros, 26 ones, 5 twos, 5 threes, 2 fours, 3 fives, 7 sixes, and 451 sevens. Wow, majority.
Go to the website I showed you.
Which one?
Yeah, I deemed it.
Okay. Let's have a look. Ooh.
Okay, interesting. So apparently this was the average score was even higher than last year's problem 1.
Yeah. Most people solved it.
Yeah.
Like most participants solved the question completely.
Well, of course. I mean, isn't that normal for problem 1? Yeah, and then like there weren't many. What?
Oh, it is
problem
not bad.
1? Yeah, of course.
Yeah.
Most participants do solve it. Yeah.
Yeah.
In fact, it's like a 5 to or a 4 to 1 ratio, I guess. Yeah.
Yeah.
All right. What about problem 2? Oh wow, problem 2. Oh right. Because problem 2 is inequality. Like nobody prepared for inequality, so that's a rip. Yeah, it's on the harder side of problem 2s apparently. Slightly, yeah. And problem 3, average score of 1. You know, I think that's on the not too bad for problem 3.
Makes sense.
Yeah.
Wow, Q4 was solved much better. What was that Q4?
Oh wow. Okay then. Isn't that? Hang on.
It's more than.
Okay.
It's more well solved in 2019 and 2018.
Yeah. I mean, 2018 is about the same apparently as this year's, which I find quite interesting. Because 2018. Wait a minute. Oh, I just realized that uh people found problem 1 in 2018 harder than problem 4? Okay, that's definitely not me.
Oh,
I did not realize that. I did not realize people found problem 4 so, like, much more
which one was
difficult.
problem 4
Problem
again?
4 is the one with,
2018?
like, the
The chessboard?
sights. Yeah, like the chessboard, and, like, you can't place
Yeah,
things
yeah.
that are knights
Root
away.
5 thing. Yeah, yeah.
Yeah.
Okay.
Alright, okay, what about problem 5?
Problem 4
Interesting.
problem 5 are pretty similar.
Wait, hang on.
In this,
I found problem 5. Well, we found
much
problem
easier.
5 way easier, right? Yeah. It took us like less than 20 minutes or something.
Yeah.
We can have a look at afterwards. Like, yeah, it'll be in the timestamps.
And problem 6, okay.
Oh, wow. How many people solved it? 4. Oh, wow.
Yeah.
Look at the distribution. There's exactly one person for...
One.
All this goes 2 to 6.
Yeah.
What kind of distribution
Did
is that,
Australia,
man?
how did Australia perform it in the questions comparatively? Let's have a
Yeah.
look. Let's look at the countries. Okay. Okay, so Australia came like what? Oh, there's a fair few people that don't like what happened. Can we order according to P6, please?
You just click P6, I guess.
Yep. Okay. Oh,
Okay.
Australia came equal what? What? A 1, 2. First, second, equal second, fourth, fifth. Equal fifth. Not bad.
For problem 6?
Yeah.
1, 2, 3, 4, 5. Oh, yeah. Okay. Wow. China gets 20.
Yeah.
Interesting.
And Australia came 7th when on the problem 3.
Okay, interesting.
I mean, I know Australia's team is particularly strong with combi, so a few of the members at least.
Huh, okay, interesting.
Hmm.
So... Yeah, so let's see. Okay, so people found... the order that people thought this was in was starting from the easiest, problem 1, then problem 4, then 5, 2, 3, 6.
Hmm.
Wait, 1...
We found problem 3 easier than problem 4.
Yeah. Rip, we just died on problem 4, Rip. 1,
Yep.
4, 5, 2, 3, 6. Yeah, I'd say the distribution for this is actually pretty good. Just like look at the distribution.
Yeah.
It's pretty good. Yeah. And I guess let's look at the graph of the results. Hey, that's a pretty good graph too. I mean, a lot of people on 7 and 0 as normal, and 14.
Yeah.
Yeah, I don't know. I thought the this year's distribution was pretty good, and one person got 42. I feel like that's the ideal, right? Like one person gets 42.
Yeah. Yeah. And Australia beating UK, that's pretty ideal. What place did New Zealand come? And what place did Sean come?
New Zealand
True
is
measure
like
of how well did the first person go?
does it even say like what rank? Oh, it does. Oh, right,
Let's
here we
see.
go. Where is it? New Zealand. We came 47th.
Not bad.
Yeah, not bad.
Good job, Ishan. Getting
Oh,
777. That's a very good score.
Man, all right. Should we look at the official solutions?
Has it been?
Should we look at the official solutions?
Yeah, probably a good idea. Wait, so New Zealand scores are G B B H H H.
I think
Bit of a
so.
rip.
Something like that. Yeah. Oh, wait, I can't open it like this. That's sad.
Good job, Brainy, getting the bronze.
What on earth? Oh, right, I downloaded it twice. Yeah, we're marking.
Wait, I just realized New Zealand #1 beat Australia #1.
Yeah, Ishan, right?
Yeah, it shan't beat
Ishan
everyone.
OP. Ishan. Ishan beat everyone in
Yeah.
APMO too.
Yeah, not surprised. Well, pleasantly surprised.
um, yeah, I'm looking at the marking scheme for problem 4. Wow, okay. Providing a complete correct model is worth 3 points for problem 4.
Wait, so the construction thing.
Yeah, the construction is worth 3 points.
Fair enough.
Wow, wow. I was not expecting that. That's a lot.
Yeah. Wow, that they used your wording for the construction.
Right, what is it? Where is it?
They used look in the solution 1. They basically used your
Solution
wording,
1.
like the same floor function and residues.
Oh, interesting.
They call it chains. We call it paths.
Right, yeah.
And general solution is, if it was just n station, there'd be n minus ceiling square root n plus 1. Fair enough. That makes sense. It's like
All right, I just realized that I implicitly assumed that the stations were numbered from 0 to n squared minus 1. Otherwise, my construction doesn't actually work.
oh, whatever.
Yeah. Because I did the floor function, but I think you're supposed to do the ceiling function.
Yeah, same thing. Basically the same thing. Okay, let's look at P5. You could reduce it to plus or minus 1 mod 4.
Oh, wait, interesting. Wait, go to, hang on. Appendix 2. Oh, interesting.
What?
They try to construct the models.
Ah. Yeah. Here's a question: how many such satisfying n squared minus n pathways are there?
Wow, okay, this is very comprehensive, the marking scheme for problem 4. Let's check 5.
Hmm.
how similar is the solution to our solution?
Our solution seems to be like shorter than theirs.
Yeah, I feel like. Oh right, okay.
Okay.
They have like two.
Like the thing is, we consider like the distinct numbers only because we didn't really need to. And I kind of got rid of like a lot of like this waffling on. I think.
Oh right, I see. Yeah. Yeah, no, this is good. Okay.
Wait, so proving for alpha equals a half was worth nothing, but proving for Q6.
Oh,
But for
okay.
proving between 1 and 3 less than alpha less than a half, you get a point.
Hang on, let me open this.
Estimating the angle measure of C. Ooh, that was something you were doing.
Oh, was it? Where was this?
The 1A.
Oh right.
Yeah.
Oh, rip. There's no points. Rip.
Yeah. Carefully chosen peel slices. But then proving this icon for alpha equals a half. Okay, wait. Over here it says it's 1 point, and for between 1 and 3 and 1 and 2 it's 2 points.
Oh, okay.
Okay.
Okay, interesting. So someone apparently. Wait, did anyone actually do that though? I wonder if someone actually did that. Yeah, I mean, someone got 2 points, but it might have been like additive 2.2, like 1 point or something.
Well, if someone got someone got one of all those 2 to 6 values, right?
Yeah.
Okay. There's this proof for C equals 1 over 8. Well, it's weaker than ours. So yeah, the optimal bound is like C n to the negative 1/3 times log n.
Oh, okay.
Yeah.
Interesting.
Okay, we have to concentrate on the points close to the boundary of the complex hull, which is what we have to do. So that. This is pretty cool. Wait, is dinner over yet? Is lunch over yet? I need to double check. Because we need to go eat lunch.
All right.
Double check. I remember what time lunch is. Okay, lunch ends at 2. Okay, I still have another half hour. Okay, I'm gonna head out and then have lunch because I'm hungry. I haven't had
Sure.
breakfast either, so.
Oh,
Yeah.
interesting. Apparently, there's an approach. Wait, maybe it's not a solution, right? It's just an approach. I don't know, but like, they mention down here, like they expand on the idea of like measuring all the angles. So that's interesting. I'm not sure it works though. I don't think it. They don't say it works. Well, actually, maybe. Wait, I don't know. Oh, it's part of another. It's part of a bigger solution. Yeah. I don't know. It's pretty comprehensive. I mean, oh my god, look at all of these. I wonder how long they spent preparing this. This is so comprehensive.
Oh yeah, I got 30 out of 30 for analysis.
Sorry?
Nothing.
Oh, right. Okay, so, yeah, alright, man. We should really wrap it up then.
Alright.
Cool. Well, yeah, see you guys at the next Livesolve, I guess, for now.
Yeah. The
like,
next
subscribe.
Olympiad season, 2021, 2020,
Yep.
2021. Olympiad season?
Yeah. Cool.
Yeah. Make sure you hit that like, smash that subscribe button, ring that notification bell.
Yep. Ooh, comment below
Right.
what contest you would like to see us Livesolve next, and we will consider it. All right. I'm gonna end the stream now.